Hello everyone. Welcome to Sally and Bytes. Ever wondered how databases store and retrieve your data? In these 14 videos, you'll learn DBMS, SQL, and MySQL step-by-step all in one place. Perfect for beginners, students, or anyone wanting to strengthen database skills. Let's dive in. Introduction to DBMS. Introduction to DBMS. DBMS stands for Database Management System. So, what is a database? A database is a structured collection of data stored on a computer. A structured collection of data. So what is data? Data is defined as raw facts, such as figures, symbols, and numbers that can be used for analysis. Now, what is management system? Processed data is called information. A management system is a structured framework that helps organizations efficiently plan, control, and coordinate their activities and resources to achieve specific objectives. Now, come to the point. What is Database Management System, DBMS? A database management system, DBMS, is a software application that facilitates the storage, retrieval, and management of data in an organized and structured manner. That is, database is an organized collection of interrelated data that serves many applications. File organization refers to the structured arrangement and storage of digital or physical files, facilitating efficient access, retrieval, and management of information. Let's see an example. A school database is a comprehensive system used to manage and organize information related to educational institutions. It typically includes information about students, teachers, courses, grades, attendance, and more. The data is arranged inside a database as per the file organization hierarchy as shown here. Data/character, data item/field record/tuple, table/file/relation, database. Let's see one by one in detail. Data or character. Data or character is the basic unit of file organization. It is represented as a bit, 0 or 1. 8 bits make a byte. A byte typically represents a character, for example, a letter, digit, or symbol, in a computer. Characters are crucial for encoding and processing information in computing systems. Data encompasses raw, unprocessed facts, figures, or information. A character is a single unit of data that represents a text or numeric element in computing and communication systems. In this student table, you will find the following data: 1001, Alice, 16, and 92. Next is the data item or field. Understanding data items or fields. A data item or field is a smaller unit of data within a record or data structure. It is like a small piece of information that tells us something specific about an entity. In student database, student. Versatility of fields. Fields can store various types of data, such as text, numbers, dates, or binary data. Naming and significance. Fields are named to describe the information they hold, example, name, age, marks. Importance of fields. They are fundamental for organizing and storing structured data in databases and data structures. In this student table, you will find the following data item or field: roll number, name, age, and marks. So, data item or field is a small piece of information that tells us something specific about an entity, student, in this student table. What is a record? Structured data collection. A record is a structured collection of related data fields or data items. Individual entries. Each record represents an individual entry, containing data fields relevant to a specific entity. Data organization. Records are essential for organizing and managing data efficiently, making it easier to store, retrieve, and work with structured information. In this student table, you will find the following student record, which consists of the fields roll number, name, age, and marks. That is 1001, Alice, 1692. A table can also be called as a file or relation. A table or file or relation is a structured collection of logically related records, organized into rows and columns. Rows in a table represent individual records or entries or tuples. Columns represent attributes or fields describing the data. For example, the entire information about all the students, in the form of records, in a class is kept in a file or table named student. Database. A database is an organized collection of data used for efficient storage, retrieval, and management in various applications. It is the highest unit of file organization. For example, student file or table, employee file, personnel file, etc. Let's see the file organization hierarchy. Start from down. You can see data or character. 1001, Alice, 16, 92. Data item or field or column or attribute as roll number, name, age, marks. Record or tuple or row given here is one student record with roll number 1001, name Alice, age 16 and marks 92. Next is file or table. Student table, the complete data of all students. Finally, the database contains many different files like student file, employee file, library file, etc. Hope you have understood the file organization hierarchy. Now, you can pause the video and try to recall what you have learnt now. Use of database in real-life situations. Let's see the application and database to maintain datasheet. Flight reservation system. Passenger information, name, contact details, flight number, departure/arrival times, seat availability and bookings, payment information, airport and airline information. Train reservation system. Passenger information, name, contact details, train number, departure/arrival times, seat availability and bookings, payment information, station and railway information. Library system. Book information, title, author, member information, name, contact details, borrowing history, due dates and fines. Inventory status. University's student information system. Student information, name, ID, contact details, course information, course code, name, schedule, enrollment records, grade records, financial information, tuition fees, scholarships. Credit card transactions. Cardholder information, name, card number, transaction details, date, amount, merchant, payment history. Online shopping sites. Product information, name, description, price, customer information, name, shipping address, order history, payment information, inventory status. Banking. Customer information, name, account number, account balances, transaction history, loan and mortgage information, ATM and branch location information. Database Management System, DBMS. A database management system, DBMS, is a software that provides an interface for users and applications to interact with a database. It manages the storage, organization, retrieval, and manipulation of data within a database. The purpose of DBMS software is to allow the user to create, modify, and control a database. Role of Database Management System. DBMS manages data storage, retrieval, and manipulation. Ensures data integrity and security. Reduces redundancy and supports multiple users. Enables data backup, recovery, and version control. Now, let's discuss about the roles. First one is data administration. It oversees data assets and governance. Manages data quality and security. Defines policies, standards, and metadata. Aligns data strategies with business goals. The second one is database technology and management. It includes database tools and models. Covers design, indexing, and performance. Manages backup, recovery, and scalability. Third one is data planning and modeling methodology. Defines data requirements and objectives. Creates visual data representations. Supports efficient database design. Forms the foundation for development. Fourth one is users. Users interact with the database system. Includes end users and administrators. Perform data operations or manage the system. User roles and permissions control data access. Examples of database management system are MS Access, MySQL, PostgreSQL, SQLite, Microsoft SQL Server, Oracle, SAP DBase, FoxPro. A DBMS provides us with the means to structurally store data. Query the database, pose data-related questions. Sort and manipulate database content. Validate input data and identify inconsistencies. Generate flexible, comprehensible reports on screen and in print. So what is the need for DBMS? The first point is to manage large amount of data without redundancy, repetition. Eliminating redundancy. Redundant data can lead to inconsistencies, increased storage requirements, and higher maintenance efforts. DBMS allows for data normalization, reducing duplication by structuring data logically and storing it efficiently. Second point is to manage large amount of data without complexity. Data modeling. DBMS provides tools for creating clear and structured data models. This modeling ensures that data is organized in a way that is easy to understand and work with, reducing complexity. The third point is to maintain data uniformly in different places or life. Data consistency. A DBMS enforces data integrity constraints and standards. This ensures that data remains consistent across various locations or time periods, preventing discrepancies or errors. Easy and convenient retrieval of data from any place or file. Query capabilities. DBMS offers a structured query language, SQL, that allows users to easily retrieve specific data from the database. The ability to search, filter, and sort data simplifies the process of finding the required information. The fourth point is control data sharing at different user level. Access control. A DBMS includes access control mechanisms that allow administrators to define and enforce user-level permissions. This ensures that only authorized users can access, modify, or delete data, enhancing data security. Let's see the components of database system. Point 1. Users in a database system interact with the system to perform various tasks, such as managing and accessing data. Users can be categorized based on their roles, including those involved in database creation, maintenance, and processing like DB administrator, system or application developers, and end users. A. Database creation. Users in a database system create and design databases by defining their structure, including tables, relationships, and data constraints. They use DBMS tools to establish the schema and data types for storing information in the database. B. Database maintenance. Maintenance users ensure the database's health and performance. They perform tasks like backup, optimization, data management, schema changes, and data integrity maintenance. C. Database processing. Database processing users interact with the database using SQL or similar query languages for tasks like data retrieval, updates, and deletions. They include end users, developers, and data analysts who rely on the database for their work. Point 2. Database application. Database applications are software programs that interact with the DBMS. They come in various types, like transaction systems, data warehouses, and business intelligence tools. These applications offer user interfaces, including web, mobile, and desktop interfaces. Components of database system continues. Point 3. DBMS, Database Management System. The DBMS is the central component of the database system. It manages data storage, retrieval, security, data integrity, concurrency control, and transactions. Popular DBMS options include MySQL, Oracle, SQL Server, and PostgreSQL, each with unique features. Point 4. Database. The database is a structured collection of data with a predefined schema. It stores data in tables, enforcing data integrity constraints. Databases vary in size and usage, from small single-user systems to large, multi-user systems for various purposes, such as managing customer data, inventory, and financial records. Advantages of a DBMS. Elimination of data redundancy. A DBMS reduces data redundancy by centralizing data storage, ensuring that each piece of information is stored only once, minimizing the risk of inconsistencies and errors. This not only saves storage space but also makes data maintenance more efficient, as updates are applied in one place, benefiting data quality and reliability. Data consistency. With a DBMS, data consistency is ensured by enforcing integrity constraints, which prevent the entry of inconsistent or incorrect data. This results in reliable, accurate, and uniform data throughout the database, crucial for decision-making and operations. Sharing of data. DBMS enables multiple users to access and share data simultaneously, facilitating collaboration and real-time information exchange. This promotes efficient teamwork and decision-making across the organization. Reduced programming effort. Application development is simplified as the DBMS provides query languages and APIs for data retrieval and manipulation. Developers can focus on application logic rather than low-level data access, saving time and effort. Database enforces standards. DBMS enforces data standards and ensures that data is stored consistently and in a structured manner. This standardization simplifies data management, data integration, and reporting. Advantages of a DBMS continues. Improved data integrity. The DBMS enforces data integrity rules and constraints to maintain the accuracy and reliability of data. This prevents unauthorized or accidental data modifications, enhancing the trustworthiness of the data. Privacy and security. DBMS provides robust security features like user authentication, authorization, and encryption to safeguard sensitive data. This helps protect data from unauthorized access and ensures compliance with privacy regulations. Economical. While initial setup costs may be high, the centralized data storage and management offered by DBMS can lead to cost savings in the long run. It reduces data redundancy, simplifies maintenance, and streamlines operations. Improved backup and recovery system. DBMS offers backup and recovery mechanisms, reducing the risk of data loss due to hardware failures or human errors. This ensures data availability and minimizes downtime. Meeting enterprise requirements. DBMS is designed to meet the complex data needs of large enterprises, offering scalability and support for diverse business processes. It's more suitable for handling the multifaceted requirements of organizations compared to individual data management solutions. I have provided all the essential key points for each heading in this chapter, which will make it easier for you to study and prepare for your exams. DBMS models. Let's learn about DBMS models. So, what's a data model? Data models are conceptual tools, like blueprints, for databases, outlining how data is structured. They define data types, what kinds of data can be stored. Relationships, how data elements are connected. Constraints, rules for data integrity and organization. Characteristics of a good data model. Data models are ideally represented through visual means, employing diagrams and symbols for clear and intuitive communication. In a data model, data representation should be free from any unnecessary duplication or repetition, ensuring a clean and efficient structure. A data model should be accessible and easily shareable among multiple applications. The data in a model should always be dependable, steady, and correct in every way. Let's discuss about the types or classification of data models. Data models are classified as object-based data models, record-based data models, and physical data models. Record-based data models are classified into hierarchical model, tree structures, network model, directed graphs, and relational model, files or tables or relations. Let's see the record-based data models one by one. Let's learn about the hierarchical model, tree structures. Key points about a hierarchical data model. Tree structure. In a hierarchical model, data records are organized in a tree-like structure rather than a graph. It resembles an upside-down tree. Hierarchy representation. This model represents a clear hierarchy, where each data element is a part of a parent-child relationship. Each element in the hierarchy has a specific parent except for the top-level element. One-to-many relationships. The hierarchical model typically depicts one-to-many, 1:m relationships, where a parent segment can have multiple child segments. This allows for the representation of complex and multi-level data relationships. One parent, many children. In this model, each parent segment can have multiple child segments, but each child segment can only have one parent. This enforces a strict, one-way relationship from parent to child. We can see the hierarchical model, tree structures, here. We can see that the student database contains various files like library file, fees file, and exam file, related to a student. In this kind of arrangement, a file higher in the hierarchy is known as parent of the files contained inside it. We can see the parent file on the top level. Here, student is a parent of the library, fees, and exam files respectively. Thus, this model represents a one-to-many relationship between a parent and its children in the form of a hierarchical, upside-down, tree. Advantages of hierarchical model, tree structures. Simplicity. This model is easy to understand and use due to its straightforward design. Enhanced data sharing. It encourages the sharing of data among different branches of the hierarchy. Data integrity. The parent-child relationship ensures that data remains consistent and maintains its accuracy. Efficiency and scalability. It's an efficient system that naturally accommodates one-to-many, 1:m relationships, making it ideal for handling diverse connections and expanding datasets. Limitations of hierarchical model, tree structures. Inflexibility for non-hierarchical data. This model works well only with hierarchical relationships, making it inflexible for mapping non-hierarchical connections. Complex implementation. Building this structure is complicated and resource-intensive because it relies on using pointers from a parent to its children, which demands additional memory space. Parent mode dependency. The entire model is heavily reliant on the root node, parent node. Deleting the root node can result in the deletion of all child nodes and, consequently, the entire structure. Application update. Changes in the structure require changes in all the applications. Examples of hierarchical model, tree structures. Both IBM's IMS, Information Management System, and System 2000 utilize hierarchical models with tree structures for data organization and management. Let's learn about network model, directed graphs. Key points about the network model. Flexible representation. The network model is a database model that provides flexibility in representing objects and their relationships. Records and links. It consists of records connected to each other through links, creating a network-like structure. Replacing hierarchy. Unlike the hierarchical model, it replaces a rigid hierarchy with a more versatile graph-based structure. Many-to-many relationships. One of its significant features is the ability to handle many-to-many, m::m relationships, where a child can have multiple parents. We can see the network model here. It is clear that this model represents many-to-many relationships. It can be observed that the file exam is associated with 3 tables, library, fees, and student. Thus this model shows that a child can have more than one parent. This model is an improved version of hierarchical model which we have seen before, having records along with pointers. These pointers establish many-to-many relationships and are termed as links. Each record has its respective pointer or link with which it is associated. We can see the red double-headed arrows here called links. It consists of all the files, student, library, exam and fees are connected to each other through links, creating a network-like structure. Advantages of network model, directed graphs. Handles complex relationships, supports many-to-many, M-is-to-M, multi-parent relationships, making it suitable for modeling complex data connections. Flexible data access. Provides easy and flexible data access, enabling efficient retrieval and manipulation of data. DDL and DML. Includes both data definition language, DDL, and data manipulation language, DML, allowing for data definition and data manipulation within the model. Enhanced data integrity. Promotes better data integrity by enforcing referential integrity constraints and minimizing data redundancy through the use of pointers or links between records. Limitations of network model, directed graphs. Complex structure. The model is structurally complicated due to numerous links, which can hinder efficiency and increase the complexity of data management. Application program changes. Structural changes require changes to be made in all application programs. High-level language requirement. A high-level language interface is required to interact with the database. Increased memory usage. The model consumes additional memory to store links or pointers. Examples of network model, directed graphs. Univax DMS 1100 and IDMS, Integrated Database Management System, are examples of network database management system. Next we are going to learn about the most popular data model in DBMS is the relational model, files or tables or relations. Popularity. The relational model is the most popular data model in database management systems, DBMS. Scientific and stable. It is considered more scientific and stable compared to hierarchical or network models due to the absence of pointers. Pointer-free. Unlike other models, it doesn't use pointers in record relationships, reducing the risk of inconsistency and improving data integrity. Two-dimensional tables. Data is organized into two-dimensional tables known as relations. These tables are the foundation of the model. Interrelation. Tables or relations are related to each other, allowing for efficient data retrieval and management. E.F. Codd's contribution. The relational model was developed by E.F. Codd and serves as the basis for relational databases. Table structure. Each table contains logically related records with the same fields, making it easy to manage and query data. Data persistence. The contents of a table can be permanently saved for future use, ensuring data durability. Simplicity and efficiency. The relational model is simple and efficient, providing the necessary properties and capabilities for processing data with storage efficiency. Let's learn about relational model, files or tables or relations. A relational model is like a big collection of tables, and each table has its own special name. This model organizes the database by using these tables or relations. Let's see the characteristics of relational database. Structured data. Data is organized in a structured way, resembling rows and columns in what's called a relation. You can see in this picture, a table named student with field name, roll number, name, age, and marks are given. Here rows which are marked in red boxes represent records or tuples. Example, if you want Alice record. Then, roll number is 1001, name Alice, age 16 and marks 92. Next is the columns marked in blue boxes, also known as fields or attributes. Our roll number, name, age, and marks columns. And finally the table marked in yellow box is also called a relation. The next characteristics is the tabular representation. Each relation is represented as a table or file, making it easy to understand and work with. Here student is the table name. Next is the attributes. The columns in a table describe the field or attributes of an entity being modeled, such as a person or product. Entity rows. Every row in a table represents a single entity, like a specific person or item. Rows are represented as tuples or records. Scalar values. Each cell in the table holds only one value or data. It's simple and not a mix of multiple things. Operations on entire relations. All operations are performed on the whole relation or table, and the result is also a complete table. Relational data model represents many-to-many relationships which can be established using primary and foreign keys. Primary and foreign keys will be discussed in the next video, Relational Database and SQL Part 3. Advantages of relational model. Structural independence. A relational model provides structural independence by using independent tables. Data consistency. Modifications to the table structure do not affect the data access or other application programs. Tabular representation. Data is presented in a tabular format, making it easily comprehensible and straightforward for users to understand. Database design ease. The tabular view simplifies the database design process, making it user-friendly for creation, utilization, implementation, and management. SQL support. Relational Database Management Systems, RDBMS, offer built-in support for structured query language, SQL, facilitating powerful and standardized data querying. Flexible data handling. Data organization and manipulation is easy, flexible, and faster. Abstraction of complexity. RDBMS systems have strong tools for organizing data and making it work efficiently. These tools hide the technical details of how data is stored, making it easier for people to use and manage the database. Mathematical operations. RDBMS systems enable successful execution of mathematical operations on data, expanding their utility beyond mere data storage and retrieval. Limitations of relational model. Hardware and software overheads. RDBMS systems can impose additional demands on hardware and system software, potentially requiring more computational resources, which may increase costs and complexity. Database size. As data accumulates, relational databases can become quite large, which can lead to challenges in terms of storage, performance, and maintenance. Let's see the difference between hierarchical data model, network data model, and relational data model. First point is the data structure. Hierarchical data model is a hierarchical structure with a single root and child nodes. Child nodes are organized in a tree-like fashion. Network model is a graph-like structure with nodes and edges. Nodes can have multiple parent and child nodes. Relational data model is a tabular structure with rows and columns. Data is organized in tables, and each table represents an entity. Second point is the relationships. Hierarchical data model. Parent-child relationships. Each child has exactly one parent. Network data model. Many-to-many relationships. A node can have multiple parents and children. Relational data model. Many-to-many relationships can be established using primary and foreign keys. Third point is the flexibility. Hierarchical data model, limited flexibility. It enforces a strict hierarchical structure. Network data model. More flexible than hierarchical, but less so than relational. Supports various relationships, but not as versatile as relational. Relational data model. Highly flexible. Can represent a wide range of data structures and relationships. The fourth point is the schema. Schema in DBMS is the design of a database that describes how data is organized and related. Hierarchical data model, schema is closely tied to the hierarchical structure. It's implicit in the organization of nodes. Network data model. Schema can be more explicit but is still somewhat tied to the graph structure. Relational data model. Explicitly defined schema with tables, columns, and keys. Fifth point is data integrity. Hierarchical data model. Enforces data integrity through hierarchical relationships. Network data model. Data integrity is maintained, but it can be complex due to multiple relationships. Relational data model. Data integrity is maintained through primary and foreign key constraints and normalization. Sixth point is the scalability. Hierarchical data model. May be less scalable for certain data access patterns. Network data model. Scalability depends on the specific implementation. Relational data model. Relational databases are well established and can scale efficiently. Seventh point is the atomicity. Hierarchical data model. Operations are often atomic at the node or edge level. Network data model. Atomicity depends on the specific implementation. Relational data model. Supports atomicity at the transaction level. Eighth point is querying. Hierarchical data model. Typically uses specialized query languages, for example, XML query languages. Network data model. Specialized query languages or extensions to query graph structures. Relational data model. Standardized query language, SQL, structured query language, is used for querying. Ninth point is use cases. Hierarchical data model. Suitable for data with a clear hierarchical structure, such as file systems and XML data. Network data model. Suitable for data with complex relationships, such as network data and some specialized applications. Relational data model. Versatile and suitable for a wide range of data types and applications. 10th point is historical significance. Hierarchical data model. Historically used in older database systems and specific applications. Network data model. Historically used in some database systems and niche applications. Relational data model. widely adopted and used in many modern applications and systems. RDBMS concepts and database keys. We have already learned about relational database in the previous video, Relational Database and SQL, Part 2. Now let's have a quick recap. Relational databases store and provide access to related data points. They are based on the relational model, using tables to represent data. Each row in a table is a record with a unique ID called the key. Columns in the table hold attributes of the entity. If student is the table, entity means name of the table student. And attributes define what information is stored for each student in the database, like roll number, name, age, marks. And each record has values for these attributes. This structure makes it easy to establish relationships among data points. Data in relational databases is typically organized into tables. Let's discuss about the basic terminologies related to a relational database: entity, attribute, tuple, cardinality of relation, degree of relation, domain of relation, and body of the relation. Let's learn about entity. In database design, entities represent what will become tables during implementation. They can store some information. The term entity is used to describe a person, a place, an object, a thing. Entity is an object which can be distinctly identified. Entity becomes the name of the table. For example, student entity, employee entity, item entity, etc. Entities are made up of many attributes. So what's an attribute? Attributes are the specific characteristics of an entity. Attributes will become fields during implementation. Now, look at the student table or relation. It consists of 4 fields or attributes, that is roll number, name, address, and gender. Attributes are set of values of a particular type. It represents columns or fields. Each row can be broken into smaller entities known as fields or attributes or columns. What's a tuple? Each row in a table is called a tuple. It is also represented as a row or record. A single entry in a table is called a record or row. A record in a table represents a set of related data. For example, now, look at the student table given here, which has 5 records. Each row or tuple in a table or relation corresponds to data of a real-world entity. For example, student, employee, and attendance. Cardinality of relation is the number of records or rows or tuples in the table or relation. The number of records or rows or tuples in this student table or relation is 5. And so, the cardinality of this student relation is 5. The number of columns or fields or attributes is known as degree of a relation. The degree of student relation is 4. The 4 columns roll number, name, address, and gender. Domain of a relation defines the kind of data represented by the attribute or field or column. It is a set of all possible values that an attribute may contain. Now, look at the student table. Domain for the field gender is 2, since it can be either M for male or F for female as the possible and available values that it may contain. In a relational database, the body of a relation refers to the actual data stored within a specific table. This data is organized as an unordered set of 0 or more tuples, rows, or records, and it forms the core structure of a relational database. Now, come on, let's recall. There are 5 tuples, that is, cardinality equals 5, and 4 attributes, that is, degree equals 4. Roll number, name, address, gender are the attribute names. The first tuple contains the values 1, Alice, Central Park, F. The domain of the attribute gender is 2, M, F. I hope you've grasped the database concepts. Let's move on to the database keys. In a relational database, keys ensure that any record in a table can be uniquely identified by one field or a combination of fields in the table. Keys also link tables in the database together and identify relationships between them. The different types of keys in an RDBMS are primary key, candidate key, alternate key, and foreign key. Let's discuss these keys in detail. The primary key. The primary key is a field which uniquely identifies each record in a table in a relational database. Let's see the salient features of a primary key. Uniqueness. A primary key ensures that each value in the primary key column is unique, preventing the existence of duplicate values within that column. Now let me explain. You can see the table item, left side table. Here item underscore ID is the primary key. Here, now check the values of the item underscore ID. 1005, 1002, 1008, 1004, 1001, and 1006. No 2 rows in the table can have the same value in this column. Same way you can check in the supplier table on the right side of the screen too. The supplier underscore ID is the primary key. So, each value in the primary column is unique. The primary key constraint ensures that no two records, rows, in the table can have identical values in the designated primary key column. This uniqueness constraint is vital for maintaining data integrity and avoiding data redundancy. It arranges the table in its own order, making data retrieval more efficient. This means a primary key, which is often used as an index, organizes the data in the table in a specific order. Searching for and retrieving specific rows becomes faster and more efficient. This is because the database system can use the index created by the primary key to quickly locate the desired data. Not null constraint. It enforces the rule that the primary key column cannot contain null, missing, values. Every row must have a valid, non-null value in the primary key column. It cannot be left empty or contain missing data. Here, in table item, the item_id column must have a valid values. Similarly, in the table supplier, the supplier_id column should have valid values. It cannot be left empty or contain missing data. One table can have only one primary key. Now, look at the table item. It can have only one primary key, item_id. Same way, look at the table supplier. It can have only one primary key, supplier_id. Now listen carefully. However, primary key can be a combination of more than one field. For example, roll_number along with admission_number can be combined together and can be declared as a primary key in the student table. In the given tables here, item_id is the primary key while supplier_id is the primary key in the table supplier. Next is the candidate key. A candidate key refers to all the attributes or columns in a table or relation that are candidates or are capable of becoming a primary key. A candidate key is any set of attributes or columns that could potentially serve as the primary key. It means that the combination of values in these attributes is unique for each row in the table. A table may have more than one candidate key, but only one of them will be chosen as the primary key. Now, look at the table item. Here item_id and item_name are the candidate keys. Out of these keys, item_id is the primary key and item_name becomes the alternate key. In the same way, in the case of supplier table, supplier_id and area are the candidate keys. Supplier_id is the primary key and area becomes the alternate key. Thus the equation candidate keys minus primary key equals alternate key. So, what is an alternate key? A candidate key that is not the primary key is called the alternate key. That means any column or attribute that is a candidate for the primary key, that is which is capable of becoming a primary key but is not a primary key, is an alternate key. Now, look at the table item on the left side of the screen. Item_name is the alternate key. Similarly, in the table supplier on the right side of the screen, area is the alternate key. Let's learn about the foreign key. A foreign key is a non-key attribute or column whose value is derived from the primary key of another table. In other words, a foreign key establishes a relationship between tables by linking data in one table to data in another table. Some key points about foreign keys are: first key point is primary-secondary relationship. A foreign key creates a primary-secondary relationship between two tables. The table containing the foreign key is considered the secondary or child table, and the table to which it refers is the primary or parent table. Now, look at the tables. You have department table on the right side of the screen, which is the primary or parent table, and employee table on the left-hand side is the secondary or child table. In the department table, dsig_code is the primary key, which when related with the table employee, becomes a foreign key to it. Again, I repeat. In the department table, dsig_code is the primary key, which when related with the table employee, becomes a foreign key to it. Second key point is referential integrity. Referential integrity is like the rulebook of a database, making sure that all the data fits together correctly, just like you follow rules when playing a game or assembling a puzzle to make sure everything works as it should. Foreign keys help maintain referential integrity, which means that data in the database remains consistent. Consistent means, it's like making sure that the puzzle piece with a straight edge fits with the outer edge of your puzzle. They prevent the creation of orphan records in the child table by ensuring that every value in the foreign key column of the child table exists in the primary key column of the parent table. Here orphan records means, it's like making sure that every puzzle piece in your jigsaw puzzle is connected, and none are missing. Now, let's see the definition of referential integrity. Referential integrity is a constraint in the database that enforces the relationship between two tables. It requires that values in a foreign key column must either be present in the primary key that is referenced by the foreign key or they must be null. Now, look at these tables. The values in a foreign key column dsig_code must either be present in the primary key of the department table that is referenced by the foreign key. As per the referential constraint, any value which does not exist as a primary key in the parent table, department, cannot be taken in the child table, employee. Now, look at the employee table. You cannot insert a new employee record with dsig_code as sale_hd, sales head, in the employee table, as there is no such dsig_code existing in the base table, that is parent table department. Otherwise, it will violate the referential integrity constraint and shall result in an error. Key points to be remembered while defining primary key and foreign key. A foreign key links the child table to the parent table's primary key, ensuring that records in the child table must reference existing values in the parent table to be added or modified. Now, look at the tables. As I have explained in the previous screen, you cannot insert a new employee record with dsig_code as sale_hd, sales head, in the employee table, as there is no such dsig_code existing in the base table, that is parent table department. Records in the parent table cannot be deleted if the corresponding records already exist in the child table. Now look at the department table, the parent table. You cannot delete a record from the parent table, say ACC as dsig_code, as its corresponding record, for Oliver, is already defined in the child table. You can look at the Oliver record in the employee table, that is the child table, ACC as dsig_code. If you wish to do this, you have to delete the corresponding record from child table as well and then delete it from the parent table. This is because of the purpose of the foreign key is to ensure the referential integrity of the data values that are supposed to appear in the tables, or in the database. Hope you have grasped the database concepts. We've concluded our study of them. In the next video, we will learn about the implementation using SQL. Introduction to MySQL. Welcome to SQL. The world is full of data. Every application or app we use is full of data. Data is a collection of information or raw facts. In today's context, virtually every organization relies on a database management system, DBMS, to handle their data and records. For example, online phone directories employ DBMS to store information about individuals, phone numbers, and contact details. Additionally, utility companies use DBMS to oversee tasks like client electricity billing, fault data management, and other client-related matters. Furthermore, a platform like Facebook heavily depends on DBMS to store, process, and display data pertaining to its users, their connections, activities, messages, advertisements, and various other elements. How do these apps store data? All these real-life applications require a DBMS database management system to manipulate and handle their enormous data. DBMS requires some language to handle and manipulate its data, which is known as Structured Query Language, SQL. Let's see the overview of SQL and MySQL. SQL is the structured query language. SQL is a standard language used for accessing and manipulating databases. SQL commands are used to create, transform, and retrieve information from Relational Database Management System, RDBMS. It is also used to create an interface between a user and a database. Using SQL commands, we can search any data from the database and perform other functions like creating tables, adding records, modifying data, removing rows, dropping tables, etc. So what is MySQL? MySQL is an open-source and freely available relational database management system, RDBMS, that uses structured query language, SQL. Open source means, here, MySQL is publicly accessible, modifiable, and distributable under specific licenses, promoting transparency, collaboration, and cost-effectiveness. It provides excellent features for creating, storing, maintaining, and accessing data stored in the form of databases and their respective tables. A single MySQL database can store several tables at a time and can store thousands of records in it. It can be downloaded from the site www.mysql.org. MySQL is fully secured, reliable, and fast and possesses far better functionalities than many other commercial RDBMS available in the market. Let's discuss about the advantages of MySQL. Scalability. MySQL can handle small to large-scale databases, making it suitable for a wide range of applications. Performance. It is known for its fast data retrieval and storage capabilities, making it efficient for data-driven applications. Reliability. MySQL provides robust data integrity and backup features, ensuring data consistency and reliability. Open source. Being open source, it's cost-effective and supported by a vast community of developers. Security. MySQL includes security features like user authentication, encryption, and access control to protect data. Multi-platform support. It supports several different platforms like Unix, Linux, macOS, and Microsoft Windows. High availability. MySQL supports features like replication and clustering for high availability and fault tolerance. Ease of use. It has a user-friendly interface and SQL compatibility, making it accessible to developers and administrators. Community support. A large and active community provides extensive resources and support. Integration. MySQL can be integrated with various programming languages and frameworks, enhancing its versatility. SQL, Structured Query Language, is a unified non-procedural language used for creating, accessing, handling and managing data in relational databases. Unified means SQL is considered unified because it provides a single language for various database operations, such as querying, inserting, updating, and deleting data. It's a comprehensive language that works across different relational database systems. Non-procedural means SQL is non-procedural because it focuses on what you want to achieve with your data, declarative, rather than how to achieve it, procedural. In other words, you describe the result you want, and the DBMS determines the most efficient way to execute the query. This is in contrast to procedural programming languages like C or Python, where you specify step-by-step instructions for how a task should be carried out. Let's discuss the feature of SQL data retrieval. SQL can retrieve data from a database through query processing. Retrieving in databases refers to fetching specific data using queries or requests. Data insertion. SQL can insert records in a database. Data updating. SQL can update records in a database. Database management. SQL can create new databases and modify existing ones. Table management. SQL can create new tables in a database. View creation. SQL allows the creation of views in a database. Security management. SQL permits modifying the security settings of the system. Let's see the advantages of SQL. Ease of use. It is very easy to learn and use and does not require high-end professional training to work upon it. Scalability. Large volume of databases can be handled quite easily. No coding required. It is non-procedural and a unified language. That is, we need not specify the procedures to accomplish a task but only need to give a command to perform the activity. Interoperability with high-level languages. SQL can be linked to most of the other high-level languages, which makes it the first choice for database programmers. Portable. It is compatible with other database programs like DBase4, FoxPro, MS Access, DBZ, MS SQL Server, Oracle, Sybase, etc. SQL is not a case-sensitive language, that is both capital and small letters are recognized. SQL is the language used to interact with the database. The SQL statements or commands that we type are the statements that are regarded as the instructions to the database. SQL provides different types of statements for different purposes. These statements are classified into categories that you can see on the screen. DDL, Data Definition Language. DDL is used for defining and managing the structure of a database. It includes commands such as create, for creating tables, indexes, and other database objects, alter, for modifying the structure, and drop, for deleting objects. The truncate statement is often categorized as part of the data definition language, DDL, because it is used to remove all the data from a table, effectively resetting the table to an empty state. While it does not alter the structure of the table, it is considered a DDL statement because it has significant implications for the database structure in terms of freeing up space and resetting auto-incrementing values, for example. Next is DML. Data Manipulation Language. DML is used for manipulating the data stored in the database. It includes commands like insert, for adding new records, update, for modifying existing records, and delete, for removing records. Next is DQL. Data Query Language. DQL is used for querying or retrieving data from a database. It primarily consists of the select statement, which allows you to retrieve specific data from one or more database tables based on specified criteria. Next is DCL. Data Control Language. DCL is responsible for controlling access to data within a database. It includes commands like grant and revoke, which manage permissions and access rights for users and roles. And finally, TCL. Transaction Control Language. TCL is used to manage transactions within a database. It includes commands like commit, to save changes, and rollback, to undo changes, ensuring the integrity and consistency of data in a database during transactions. We will be discussing DDL, DML, and DQL, as DCL and TCL are not within the scope of this syllabus. Let's discuss about Data Definition Language, DDL. The DDL part of SQL permits database tables to be created or deleted. It also defines indices, keys, specifies links between tables, and imposes constraints on tables. Constraints refer to rules and conditions that are defined to control the type and integrity of data that can be stored in a table. It contains necessary statements for creating, manipulating, altering, and deleting the table. The data definition language commands enable us to specify the database's structure and perform actions related to that structure. The query and update commands, which are part of SQL's data manipulation language, DML, empower users to retrieve or modify data stored within a database. Examples of DDL commands in SQL are: create database, creates a new database, use command, to select and open an already existing database, show command, to display all the tables in an existing database, create table, creates a new table in an existing database, alter table, modifies the structure of a table, drop table, deletes a table. Data manipulation language, DML, commands. These are a component of SQL's data manipulation language, DML, and are used as tools for users to manipulate data in a database. Query execution. DML commands are executed in the form of queries and are managed by the DML compiler. It contains the set of statements to insert data into tables of the database, delete data from the tables of the database, update data among the rows or records in the tables of the database. DML commands carry out query processing operations and manipulate data in the database objects. Several DML commands available are: insert into statement, to insert new data, record, into a table. Update statement, to modify or change the data, tuple, in a table, not modifying the data type of column. Delete, to delete data, tuple, from a table, not deleting a column. Difference between DDL and DML commands. DDL stands for Data Definition Language. DML stands for Data Manipulation Language. DDL commands allow us to perform tasks related to data definitions, that is, related to the structure of the database objects, relations, or databases. DML commands are used to manipulate data, that is, records or rows in a table or relation. Examples of DDL commands are create, alter, drop, etc. Examples of DML commands are insert into, update, delete, etc. DDL is not further classified, whereas DML commands are further classified into procedural DMLs and non-procedural DMLs. SQL queries in data retrieval. One of the most important tasks when working with SQL is to creating queries to extract data from a database. A query is an instruction to obtain specific information from a database table. The select command is the primary tool for crafting queries and retrieving data from database tables. It is used to retrieve a subset of records from one or more tables. The syntax of select command is select column list from table name semicolon. Column list includes one or more columns from which data is retrieved. We will be discussing the DDL, DML, and DQL commands in detail in the upcoming videos. SQL data types and constraints. SQL, Structured Query Language, supports various data types to store and manipulate different types of data in a relational database. In SQL, each column of the table is assigned a data type which conveys the kind of value that will be stored in the column. Within MySQL, data types are organized into several categories, including numeric, non-numeric, often referred to as string types, date, and time types. While MySQL offers a wide range of data types under each of these categories, we will concentrate on some commonly used data types in MySQL. The numeric data type integer. The integer data type is capable of storing and representing whole numbers, which can be either positive or negative. It accommodates positive whole numbers with up to 11 digits and negative whole numbers with up to 10 digits. The allowable range of integers spans from -2,147,483,648, approximately -2 billion, to 2,147,483,647, approximately 2 billion. The syntax is uppercase integer or lowercase integer. The next data type is float data type. Float data type holds numbers with decimal points. Each float value occupies 4 bytes, 32 bits in memory of storage space. This data type is suitable for representing values with both whole and fractional parts, making it versatile for various numerical applications. The syntax is uppercase float or lowercase float. Data type numeric. This is quite interesting. Numeric of p(s) data type is used to represent fixed point numbers with a specified precision and scale. Here's what p and s represent. P represents the total number of digits, both to the left and right of the decimal point, that can be stored in the number. It is often referred to as the precision. It indicates the maximum number of digits in the number, including both the integer part and the decimal part. S represents the number of digits to the right of the decimal point. It is often referred to as the scale. It indicates the maximum number of decimal places that can be stored in the number. The syntax is numeric of p, s. It takes two arguments: precision of p and scale of s. Let's see some examples. Numeric of 6, 2. This specifies a numeric data type with a total precision, p, of 6 digits, and the scale, s, is 2, indicating exactly 2 digits to the right of the decimal point. Remember that numeric determines the exact precision and scale. Let's see the value 1234.67. Here the total number of digits, both to the left and right of the decimal point, is 6, that is, precision is 6. The number of digits to the right of the decimal point called scale, which is 2. This fits perfectly within the numeric of 6, 2 data type, as it matches the specified precision of 6 with 2 digits to the right of the decimal point. Now, let's see the next value. 123.45. Here, the total number of digits, both to the left and right of the decimal point, is 5, that is, precision is 5. The number of digits to the right of the decimal point called scale, which is 2. This fits perfectly within the numeric of 6, 2 data type, as it within the specified precision of 6 with 2 digits to the right of the decimal point. Let's see value 123.456. Here, the total number of digits, both to the left and right of the decimal point, is 6, that is, precision is 6. The number of digits to the right of the decimal point called scale, which is 3. This results in an error, as it does not fit perfectly within the numeric of 6, 2 data type, as the decimal part should be 2 digits on the right of the decimal point. But here it is 3 digits on the right of the decimal point. The next data type is decimal. Decimal of p, s data type is used to represent fixed point numbers with a specified precision and scale. Here's what p and s represent. P represents the total number of digits, both to the left and right of the decimal point, that can be stored in the number. It is often referred to as the precision. It indicates the maximum number of digits in the number, including both the integer part and the decimal part. The precision can be equal to or greater than what is specified by the coder, and the actual precision may vary depending on the database system. S represents the number of digits to the right of the decimal point. It is often referred to as the scale. It indicates the maximum number of decimal places that can be stored in the number. The syntax is decimal of p, s, or decimal of size, precision, or decimal point. Let's see some examples. Decimal of 6, 2 specifies a decimal data type with a scale of 2, exactly 2 digits to the right of the decimal point. However, the precision can be equal to or greater than 6, and the actual precision may vary depending on the database system. Remember that decimal specifies only the exact scale. The precision is equal or greater than what is specified by the coder. Example. Look at value 1. A value like 1234.56 will be stored as is, with 4 digits in the integer part and 2 in the decimal part. So total of 6 digits, 2 to the right of the decimal point. This fits perfectly within the decimal of 6, 2 data type. Now look at value 2. A value like 123456.78 will also be stored with 6 digits in the integer part and 2 in the decimal part, even though the precision is greater than 6. Here, the total number of digits, that is the precision, is 8 digits. It accepts the precision given as 8 digits. The precision can be equal to or greater than what is specified by the coder, and the actual precision may vary depending on the database system. Now, look at value 3. A value like 1234.567. This results in an error, as it does not fit perfectly within the decimal of 6, 2 data type, as the decimal part should be 2 digits on the right of the decimal point. But here it is 3 digits on the right of the decimal point. So, can you find the difference between numeric of p, s and decimal of p, s? Yes. There is a small difference between them. Numeric determines the exact precision and scale. Whereas, decimal specifies only the exact scale, the precision is equal or greater than what is specified by the coder. Decimal columns can have a larger than specified precision if this is more convenient or efficient for the database system. Next data type is character of fixed length. Char data type stores X number of characters in the string which has a fixed length. A maximum of 254 characters can be stored in a string. If you store strings that are not as long as the size or X parameter value, the remaining spaces are left unused. The syntax is char of X or char of size. Let's see an example. If you specify name char of 10, name equals Sam, the string Sam is 3 characters. So 3 plus 7 unused spaces are stored as 10 characters in total. So it takes 10 bytes of storage. Char data type takes memory space of 1 byte per character. As the value of string Sam is 3, the remaining 7 spaces are left unused and blanks are added. So when we want to add a name, we cannot assume the number of characters. Example, John can have 4 characters and Sophia can have 6 characters. So char data type can be used for fixed length of string. Now look at example 2. However, a student admission underscore number is 6 digits long in a school. So char of 6 would be appropriate to store the admission underscore number of all the students. Another example is PIN code of a country. So char data type is suitable where the number of characters to store is fixed. The value for char data type has to be enclosed in single or double quotation marks. The next data type is character of variable length. Varchar data type is used to store variable length alphanumeric data. Advantage is varchar data type will not leave unused spaces like the char data type. It releases the unused memory spaces. The syntax is varchar of x, example. Name varchar of 10. Name equals Sam, you can look at the picture. It has taken only the length of the string 3 bytes to store the name Sam, even though varchar of 10 is given. Varchar data type will not leave unused spaces. It releases the unused memory spaces. This demonstrates how varchar efficiently uses storage by adapting to the actual characters entered, without adding unnecessary padding or wasted space. The value for varchar data type has to be enclosed in single or double quotation marks. The char and varchar types are similar, but differ in the way they are stored and retrieved. They also differ in maximum length and in whether trailing spaces are retained. Let's see the difference between char and varchar date types. First point. Char stands for character whereas varchar stands for variable character. Second point, char stores character strings of fixed length, whereas varchar stores character strings of variable length. Third point. Char can store a maximum of 0 to 255 characters, whereas varchar can store a maximum number up to 65,535. Fourth point. The char data type is used when the data entries in a column are expected to be of the same size. An example would be an admission number of a school student. The admission numbers of the school are of uniform length. Another example is the PIN code column in a database of a country, where PIN codes are of uniform length. Whereas, the varchar data type is used when the data entries in a column are with expected variations in data size. An example of using the varchar data type is for a product description column in a database for an online store. Product descriptions can vary significantly in length, and using varchar allows you to store these descriptions efficiently while accommodating the natural variation in text length without unnecessary padding. For example, if you have a char of 10 column and you enter hello, which is 5 characters long, it will be stored as hello with 5 additional spaces added to make it a total of 10 characters. This fixed length storage ensures that every value in the column occupies the same amount of storage, maintaining consistency, but it may lead to some wasted space when storing shorter values. Whereas varchar of x minimizes storage usage by adapting to the actual characters entered. Varchar of 10 column and you enter the value hello. Hello contains 5 characters. Hello will occupy 5 bytes in storage, exactly matching the length of the text provided. This demonstrates how varchar efficiently uses storage by adapting to the actual characters entered, without adding unnecessary padding or wasted space. Sixth point. Char of x adds blanks when a value entered is shorter than its length x. So some memory space is wasted. Whereas, in varchar data type, no blanks are added if the length is shorter than the maximum length x. No wastage of memory space. Seventh point. Char data type takes memory space of 1 byte per character, whereas varchar takes up memory space of 1 byte per character, plus 2 bytes to hold variable length information. This makes varchar more space efficient for variable length strings compared to char, which reserves a fixed amount of space per character. Eighth point. In char data type, search operation is faster, as it stores fixed length of characters of a string. Whereas, in varchar, search operation is slower. Ninth point. Example, name char of 10. Name equals Sam. Here, name field occupies 10 bytes, with the first 3 bytes with values and the rest with blank data. Whereas in varchar, example, name varchar, 10, name equals Sam, name field occupies only 3 plus 2 is equal to 5 bytes, the first 3 bytes for value and the other 2 bytes for variable length information. When to use char or varchar? Use char when data is of consistent, fixed length. Data length is always the same. Space efficiency is not a primary concern. Use varchar when data length varies significantly. Ideal for text data with different lengths. Offers space efficiency as it adapts storage. Common choice for variable length data. Let's discuss about the next data type, date. Date data type is used to store a date in YYYY/MM/DD or YYYY-MM-DD format. It stores year, month, and date values. YYYY represents the year, 4 digits. MM represents the month, 2 digits, 01 to 12. DD represents the day, 2 digits, 01 to 31. Date values can be compared with each other only. The date values to be entered are to be enclosed in single quotation marks. Example, 2023-05-16. When working with dates, you have to be sure that the format of the date you are trying to insert matches the format of the date column in the database. The date data type is commonly used for various purposes, such as tracking events, managing schedules, and recording dates of transactions or events. It is useful for storing and working with date-related information in a database, and it ensures data consistency and accuracy when dealing with date values. The next data type is time. Time data type is used to store time in HH:MM:SS format. It stores hour, minute, and second values. HH represents the hour, 00 to 23. MM represents the minutes, 00 to 59. SS represents the seconds, 00 to 59. For example, a time of a day can be taken as 10:15:30, where 10 refers to hours, 15 refers to minutes, and 30 refers to seconds. The time data type is used to store and manipulate time-related information in a database. It's useful for tasks like recording timestamps, scheduling events, and tracking the duration of events. When combined with date or datetime data types, it can represent full timestamps with both date and time components. Constraints in SQL. We will discuss about some commonly used constraints in SQL. SQL constraints are used to specify rules for the data in a table. Constraints are used to limit the type of data that can go into a table. This ensures the accuracy and reliability of the data in the table. The first constraint is the primary key constraint. The field or attribute or column which uniquely identifies each row or record in a table is the primary key. Primary key is a combination of a not null and unique. Primary keys must contain unique values and cannot contain null values. A table can have only one primary key, and in the table, this primary key can consist of single or multiple columns, fields. Suppose you have a table named employee with the following columns. Employee_ID, primary key, name, department. The employee_ID column is defined as the primary key. Each value in the employee_ID column must be unique for each employee. There cannot be two employees with the same employee_ID. The employee_ID column cannot contain null values. It must have a valid identifier for each employee. Let's see an example. SQL primary key on create table is given here. We are creating a table named employee. Here, employee_ID and name has the constraint not null, that means these fields should contain value, it should not be allowed blank. And employee_ID is the primary key of this table employee. Some commonly used constraints are not null constraint. It ensures that a column cannot have a null value. Null means missing or unknown or not applicable value. This enforces a field to always contain a value, which means that you cannot insert a new record or update a record without adding a value to this field. Sometimes an attribute or column should not be allowed blank. Let's see an example. SQL not null on create table is given here. We are creating a table named student. So here, ID and name has the constraint not null, that means these fields should contain value, it should not be allowed blank. Let's learn about the unique constraint. The unique constraint ensures that all values in a column are unique or distinct or different. Both the unique and primary key constraints provide a guarantee for uniqueness for a column or set of columns. A primary key constraint automatically has a unique constraint. However, you can have many unique constraints per table, but only one primary key constraint per table. Let's see an example. SQL unique on create table is given here. We are creating a table named student. Here the ID and name has the constraint not null, that means these fields should contain value, it should not be allowed blank. Now, you would have noticed that ID has the unique constraint also, that means all the IDs should be different or unique for all the students. No student can hold the same ID. Each student holds a unique or different IDs. The next SQL constraint is check. The check constraint is used to limit the value range that can be placed in a column. If you define a check constraint on a column, it will allow only certain values for this column. If you define a check constraint on a table, it can limit the values in certain columns based on values in other columns in the row. Let's see an example, SQL check on create table. The create table statement creates a table named student with 3 columns, ID, name, and age. The ID and name columns are required and cannot contain null values, while the age column must have values that are greater than or equal to 18, as per the check constraint. This table structure is suitable for storing information about students, including their ID, name, and age, with an age restriction applied to ensure that only adults, aged 18 and above, can be recorded in the table. The next constraint is the default constraint. The default constraint is used to set a default value for a column. The default value will be added to all new records if no other value is specified. Let's see an example. Now, look at the SQL statement. The create table statement creates a table named student with 4 columns, ID, name, age, and city. The ID and name columns are required and cannot contain null values. The age column can contain null values. The city column, if not specified during an insert operation, will default to Delhi. This table structure is suitable for storing information about students, including their ID, name, age, and city of residence. Let's learn about the foreign key. A foreign key is a field, or collection of fields, in one table, that refers to the primary key in another table. The table with the foreign key is called the child table, and the table with the primary key is called the referenced or parent table. Let's see the primary-secondary relationship. A foreign key creates a primary-secondary relationship between 2 tables. The table containing the foreign key is considered the secondary or child table, and the table to which it refers is the primary or parent table. Now, look at the tables. You have department table on the right side of the screen, which is the primary or parent table, and employee table on the left-hand side is the secondary or child table. In the department table, dsig_code is the primary key, which when related with the table employee, becomes a foreign key to it. Again, I explain. Notice that the dsig_code column in the department table on the right side of the screen points to the dsig_code column in the employee table, which is on the left side of the screen. The dsig_code column in the department table is the primary key in the department table. The dsig_code column in the employee table is a foreign key in the employee table. The foreign key constraint prevents invalid data from being inserted into the foreign key column, because it has to be one of the values contained in the parent table. Let's see an example for foreign key constraint. Assuming you have already created the parent table named department table with the dsig_code as the primary key, you can define the foreign key relationship in the employee table with the following SQL statement. Create table employee, open bracket, item_ID varchar of 5, primary key, emp_name varchar of 25, dsig_code varchar of 10, foreign key, dsig_code, references department, of dsig_code, close bracket semicolon. In this SQL statement, item_ID is the primary key in the employee table. emp_name is an attribute for the employee's name. dsig_code is a column in the employee table that you want to create as a foreign key. The foreign key constraint is used to specify that the dsig_code column in the employee table is a foreign key. It references the dsig_code column in the department table. This establishes a relationship where the values in the dsig_code column of the employee table must exist in the dsig_code column of the department table, which enforces referential integrity. In other words, you can't insert values in the employee table's dsig_code column that do not exist in the department table's dsig_code column. Make sure you have created the department table with the dsig_code as the primary key before running this SQL statement. How to download and install MySQL. Let's learn how to download and install MySQL on your Windows system. To install MySQL on your Windows system, you can follow these steps. Step 1. Download MySQL installer for Windows. Go to the official MySQL website to download the MySQL installer for Windows. First step is to open any browser, type the link given here. Kindly check the link which is given in the description box below for easy access. When you open the link, you will directly land on this screen. Step 2. Select MySQL installer for Windows Web Community Version. You can look at this screen. In Select Version, automatically 8.0.35 is selected, and in Select Operating System, Microsoft Windows is selected. Now you have to click on the second download button for the MySQL installer for Windows. Next, you will land on this screen. There is no need to log in or sign up. Now just click, "No thanks, just start my download." This will download an executable installer file to your computer. Now you have to save the file. As soon as you save the file, once the download is complete, you should see a file in the same location where you initiated the download. It might look like the one in the second picture on your screen. Locate the downloaded file. It's usually in your Downloads folder, or in the directory you specified during the download. Double-click on the downloaded file. This action will start the installation process. Step 3. Run the installer. Locate the downloaded installer file. It should have a .exe extension, and double-click it to run the MySQL installer. You will get a screen like this seen on the screen. Finally, you will get this screen. Step 4. Choose an installation type. Select Server Installation Type. In the MySQL installer, you can choose the server installation type, which is suitable for setting up a MySQL database server. Click on Server Only to select it. Left side of the screen, you can see the steps to follow for installation. Step 5. Select Products. Look at the left side of the screen. We are in Check Requirements. Next, you'll be presented with a list of MySQL products and features. For a basic server installation, you should select at least MySQL Server. You can also choose additional products or features based on your needs, but MySQL Server is the essential component. Here the requirement is Microsoft Visual C++. Next, click the Execute button. Now, you will receive this screen. Look at the left side of the screen. We are in Check Requirements. Step 6. Check for updates. The installer will check for updates to ensure you're installing the latest version of MySQL. If updates are available, you can choose to install them or proceed with the current version. Now, you have to click the checkbox to agree to the license terms and conditions. Then click Install button. The setup is successful now. Now click the Close button. You will land up on this screen. Look at the left side of the screen. Installation. Now, look at the bottom right corner. Click Execute button. It automatically downloads and installs MySQL Server. Step 7. Installation settings. From the previous screen, click Next button until you reach this screen. Again, click Next button. From the previous screen, click Next button until you reach this screen. Step 8. Set the root password. During the installation, you will be prompted to set a password for the MySQL root user. This is an important step, so choose a strong and secure password and remember it. Again, click Next button. Click on the Next button again. Now, we have come to the last step in installation. Apply configuration. First, click the Execute button below. You can see the green checkmark. The following steps are being executed. You can also see that initializing database may take a long time. Finally, you can see the green color checkmark in all the configuration steps. You can also see the message given below as the configuration for MySQL Server 8.0.34 was successful. Click Finish to continue. Now, click the Finish button. Now, configuration is complete. Click the Next button. Step 9. Installation complete. Once the installation is complete, you will see a screen indicating that the installation procedure has been completed. You can then close the installer. Click the Finish button. Step 10. Start MySQL Server. MySQL Server should be automatically started as a Windows service. To access it, in the search index, type MySQL. Immediately, you will receive MySQL 8.0 command line client. You have now successfully installed MySQL Server on your Windows system. Remember to keep the root password secure, as it's essential for administering your MySQL server. Now look at the screen. When you type MySQL and press Enter key, you will land on this screen. It will ask you to enter the password. Now enter the password, which you have entered at the time of installation. After entering the password, you get the display like this, seen on the screen. That means you have now successfully installed MySQL Server on your Windows system. You can see a blinking cursor where you can enter the SQL statements. We will be working with SQL statements in the upcoming videos. MySQL DDL Commands. Let's learn about SQL Commands. What is SQL Commands? SQL Commands are instructions used to interact with a relational database, including tasks like querying, updating, and managing data. To become familiar with SQL, it's important to understand the basic terminologies, which include keywords, clauses, and statements or commands, as these concepts are frequently used in SQL. Let's recall the columns or fields or attributes marked in blue boxes, rows or tuples or records marked in red boxes, and relation or table or file marked in yellow boxes. Just for reference. Already we have learnt this in detail in the previous videos. In SQL, a keyword is a reserved word with a predefined meaning, like select or from, for example. In an SQL query, select is a keyword used to retrieve data from a database table. Retrieve means to fetch or obtain data or information from a source, such as a database or a storage location. For example, select column 1 from table 1. For example, in a student table we select roll number from student table. Clause. In SQL, a clause is a component of a query that specifies conditions or actions. It is a distinct logical part of an SQL statement. Clauses begin with a keyword for which they are named and consist of arguments as well. For example, the where clause in select emp name from employee where department equals sales semicolon. Here, arguments complete or modify the meaning of the clause, which is department in the given example. In SQL, a statement or command is a combination of two or more clauses. Statements are the instructions given to SQL database for executing a task. For example, select star from employee semicolon. This is a statement or command. All SQL statements end with semicolon. Here are some key points to remember. All the statements in SQL terminate with a semicolon. SQL is not case sensitive. Therefore, we can type commands in either uppercase or lowercase. For example, look at the first statement, select star from employee semicolon. Here the statement is in uppercase. Look at the second statement. Select star from employee semicolon. Here the statement is in lowercase. Let's discuss the DDL, Data Definition Language Commands. Data Definition Language, DDL, commands in SQL are used to define, modify, and manage the structure of a database, including creating tables, altering schemas. Schema means a database schema organizes and manages tables, views, and procedures for efficient data structure. And defining constraints. A constraint in a database is a rule that enforces data integrity by defining limits or conditions for the values that can be stored in a table. These are the DDL commands. Creating databases, opening databases, showing databases, removing databases, creating a table, viewing a table structure, alter table command, and drop table command. A database is a structured collection of data organized for efficient storage and retrieval. Let's learn how to create a database. The create database command is used to create a database in RDBMS, that is Relational Database Management System. Syntax is create database _name semicolon. Example. Create database school semicolon. This statement creates database with the name school. Now, a database with the name school will be created on the system. The semicolon at the end of the command is used to terminate the SQL statement. The message query OK, 1 row affected, 0.29 seconds, typically appears after executing a SQL command in a database system like MySQL. It indicates that the query was successful, and it affected 1 row of data in this case, or it could also mean that a particular action was performed successfully. The 0.29 seconds represents the time taken to execute the query, measured in seconds. This message is a confirmation that the database operation was completed without errors and provides some timing information. Let's work practically. We have learned how to open MySQL for Windows in your system in the previous video. Now, let's open it in the search index of your system. Type MySQL, immediately MySQL command line client appears. Press Enter key. You will land on this screen. It will ask you to enter the password. Now enter the password, which you have entered at the time of installation. After entering the password, you get the display like this, seen on the screen. That means you have now successfully installed MySQL Server on your Windows system. You can see a blinking cursor where you can enter the SQL statements. Now, let's start working here. Now, we have typed, create database school semicolon. This statement creates database with the name school. Now, a database with the name school will be created on the system. Let's learn how to open a database. Once a database has been created, we need to open it to work on it. For this, use command is required. Syntax is use database _name semicolon. Let's see the practical example. We have typed use school semicolon in the MySQL prompt. When you type use school in the MySQL prompt, it is a command to select and set a specific database as the current working database. The semicolon at the end of the command is used to terminate the SQL statement. After executing this command, the message database changed is displayed. You can see it on the screen. This message database changed is to confirm that the database context has been switched to the one you specified, in this case, school. This means that any subsequent SQL commands you enter will be executed within the context of the selected database. It helps you focus your operations on a specific database rather than working with multiple databases simultaneously, which is a common practice in database management. Let's learn about how to use Show Databases command. Show Databases command displays a list of all the databases which is already created in your MySQL system. Syntax is show databases semicolon. Let's see the practical example. Here, you can see a list of all the databases displayed, which is already created in your MySQL system. The semicolon at the end of the command is used to terminate the SQL statement. Now you can see a message below the list. The message 6 rows in set 0.10 seconds is a response to the SQL command show databases in MySQL. This message confirms that the show databases command has successfully retrieved a list of all the databases in your MySQL system, and there are 6 of them. The timing information, 0.10 seconds, indicates how quickly the operation was performed. Let's learn about removing databases. To physically remove or delete a database along with all its tables, drop database command is used. The syntax is drop database_name semicolon. Let's see the practical example. We have typed drop database school semicolon. The command drop database school is a SQL command that is used to delete or drop a database named school in a database management system like MySQL. It's important to note that executing this command will permanently remove the school database and all the data it contains. The semicolon at the end of the command is used to terminate the SQL statement. Now, look at the below message. Query OK means that the query was executed without any errors. 0 rows affected means that the query did not result in any changes to the data. In other words, the query was successful, but it didn't modify any records in the database. Here, you can compare the list of databases. The original database, that us before removing school database, holds 6 rows in set. But after removing school database, we have 5 rows in set, as the school database is removed. You have to be cautious when using this drop database command, as data loss is irreversible. Let's learn how to create a table. The create table statement is used to create a table in a database. Tables are organized into rows and columns, and each table must have a name. It is the most extensively used DDL command. A table must have at least one column. The syntax is create table_name, open brackets, column_name 1, data_type, size, comma, column_name 2, data_type, size, comma, column_name 3, data_type, size, close brackets, semicolon. Now, let's see a practical example. Look at the red box. First, we are creating a database named Institute. Next, look at the blue box. We are opening the database. Syntax is use database_name. Use institute semicolon. So we are using the database Institute now. Now, look at the yellow box. We are creating a table under the Institute database. Create table student. Here student is the table name. Open brackets, roll_no roll number, which is the column name, data type integer, not null constraint is used. So column roll_no cannot have null values. Definitely we have to add values to it. Primary key constraint is used. That means roll number column name, which uniquely identifies each row or record on this student table. Next line, we enter the second column name, data type varchar of 20, not null constraint is used. That means this name column cannot have null values. Definitely we have to add values to it. Next line we have column name gender, data type char of 1. Next line we have column name marks, data type integer. Last line we have column name DOB, data type date, close brackets semicolon. Now successfully, we have created a student table under Database Institute. Note, for each column, a name and a data type must be specified and the column name must be unique within the table definition. Column definitions are separated by comma. Uppercase and lowercase letters make no difference in column names. Let's learn how to view a table. To verify that the table has been created in the database, show tables command is used. Now, let's see a practical example. In the MySQL prompt, we have typed show tables semicolon. So you can see the display. The database named Institute holds student table. Let's learn how to view a table structure. To view a table structure, describe or desc command is used. It shows the structure of the table along with the name of the column, data type of the columns and constraints applied on the columns. Now, look at the practical example. Desc student semicolon is typed in the MySQL prompt. You can view the table structure of the student, which we have created. You can view the field names, their data types, constraints like null, primary key, default, etc. Let's learn about the alter table command. The alter table command in SQL is used to modify an existing table structure. You can use this command to add, modify, or delete columns, constraints, and other table attributes. The operations performed by alter table command are adding a column to an existing table, adding a column with default value, modifying an existing column definition, renaming a column, removing a column, and adding and deleting primary key constraints. Let's see one by one in detail. Let's learn how to add a column to an existing table. To add a new column to an existing table in SQL, you can use the alter table statement. Once a table has been created, new columns can be added later on if required. The new column is added with null values for all the records or rows in the table. The syntax is alter table table_name add, column_name data type, size, semicolon. For example, we type the statement in the MySQL prompt as alter table student add open brackets mobile_no integer close brackets semicolon. So we are adding a new column mobile_no as integer data type in the student table. We have inserted 5 records in the student table. You can see the 5 records of Kevin, Rosie, David, Emily, and Alex. We will learn about how to insert values into the table in the next video, while dealing with the DML commands. Insert commands come under DML commands. So you can see how alter table works in here. As alter table and drop table falls under DDL commands, we will complete these commands first continuously for your easy learning of DDL commands. Let's view our student table with values inserted. To view our table with values inserted, we have to type the statement select star from student semicolon. Now, look at the table student here. It has 5 columns named roll_no, name, gender, marks, and DOB. We will add a new column, mobile number, to the student table using alter table command. So, we type the statement in the MySQL prompt as alter table student add open brackets mobile_no integer close brackets semicolon. Now, to view our altered table, we have to type the statement select star from student semicolon. Look at the altered student table here. What can you see? Yes, a new column. The alter table statement has added a new column mobile_no into the table student with null value in it. Now, we can insert values one by one for the mobile number too. Let's learn how to add a column with default value. Alter table command can be used to add a new column to an existing table with default values. The syntax is alter table table_name add, column_name 1, data type 1 default data, semicolon. Example. Alter table student add city Sharof 10 default Denmark semicolon. Look at the statement given. Alter table student add open brackets city Charov 10 default Denmark, place Denmark in double quotes, close brackets, semicolon. Let's view our altered table student. So we type the statement select star from student semicolon. What can you see in this altered table student? Yes. This will add a new column city with default value as Denmark to this student table. Let's learn how to modify an existing column definition. Modify command can be used with alter table command to change the data type, size, constraint related to any column of the table. The syntax is alter table table_name modify, column_name 1, data type 1, semicolon. Example. We type the statement alter table student modify name varchar of 25 semicolon. Let's see an example practically. We type the statement alter table student modify name varchar of 25 semicolon. Now, look at the yellow box. To view the table structure, we type describe or desk student semicolon. Now, here, to compare how the table structure has been altered, you can view the existing table structure of the student on the left side and the altered table structure of the student on the right side. Look at the name data type. You can see how it has altered or modified the data type to varchar of 25. Let's learn how to rename a column in a table. The existing column in a relation can be renamed using alter table command. The syntax is alter table table_name change, column_name 1, old column name new column name column_definition semicolon. For example, we type the statement alter table student change city, which is the old column name, state, which is the new column name, data type varchar 10 semicolon. Now you can see the practical example. We type the statement alter table student change city, which is the old column name, state, which is the new column name, data type varchar 10 semicolon. Now look at the yellow box. We type select star from student semicolon to view the table. What can you see? Yes, the city column is changed to state column. Here, you can compare the column name of student table, how old column name city is changed to new column name state. Let's learn how to remove a column from a table. To remove or drop a column in a table, alter table command is used. The syntax is alter table _name drop column name semicolon. For example, we type the statement alter table student drop state semicolon, where student is the table name and state is the column name. Look at the practical example. We type the statement alter table student drop state semicolon, where student is the table name and state is the column name. Now, look at the yellow box. To view the table values, we type the statement select star from student semicolon. So, what can you see? The state column is removed or dropped from the student table. Now, you can see the difference with the existing student table and the altered student table, how the state column is removed or dropped from the student table. Let's learn how to add and delete primary key constraints in an altered table. We can add or delete a primary key constraint even if the table has already been created using alter table command. Syntax to add primary key constraint is alter table _name add primary key of column name semicolon. The syntax to delete a primary key constraint is alter table _name drop primary key semicolon. Now look at the first statement. We have already created a primary key constraint while creating the student table. While creating the table student, we have set the roll _no as the primary key. You can see below the table structure too. So first we will learn how to delete the primary key constraint and then to add the primary key constraint. To delete a primary key constraint from the table student, the syntax is alter table _name drop primary key semicolon. For example, look at the statement alter table student drop primary key semicolon. Look at the MySQL statement alter table student drop primary key semicolon. Now to view the table structure, type the statement desk student semicolon. So what can you see on the student table structure? Yes, the primary key is deleted from the table student. Let's learn how to add primary key constraints. The syntax is alter table _name add primary key of column name semicolon. For example, look at the MySQL statement. Alter table student add primary key of roll _no semicolon. Now look at the MySQL statement. Alter table student add primary key of roll _no semicolon. To view the student table structure, we type the statement desk student semicolon. What can you see now? The primary key constraint is added on the column roll _no in the table student. Always remember while using alter table command to add a primary key that the primary key columns must be declared with not null constraint when the table was first created. We did it. Sometimes, we may need to physically remove a table which is not in use. Drop table command is used to remove or delete a table permanently. If you drop a table, all the rows in the table are deleted along with its structure. Once a table is dropped, we cannot get it back and all other references to the table become invalid. This command completely destroys the table structure. The syntax is drop table _name semicolon. For example, drop table student semicolon. This command will permanently remove the table student from the database institute. Now, look at the practical example. The MySQL statement is drop table student semicolon. This command will permanently remove the table student from the database institute. So to view the table, we type the statement desk student semicolon. What can you see here? An error message states that table institute.student doesn't exist. Institute is the database name where student table was stored. Please ensure that you have a good understanding of the data definition language, DDL, commands in SQL. I recommend practicing all the SQL DDL commands to reinforce your knowledge and skills. MySQL DML commands. Now in this video, we are going to learn about data manipulation language, DML, commands, which includes insert, update and delete. DML stands for data manipulation language. When we create a table, only its structure is created but the table has no data. To add records in the table, insert statement is used. Also, table records can be deleted or updated using delete and update statements. These SQL statements are part of data manipulation commands, DML. Data manipulation using a database means either insertion of new data, removal of existing data or modification of existing data in the database. Let's learn about how to insert data into a table. The insert into command is used to insert a new record or row or tuple in a table. It is possible to write the insert into statement in different forms. The first form is inserting data for all the columns into a table. In this first method, it specifies only the values, that is data to be inserted. It does not specify the column names. The syntax is insert into table underscore name values, value 1, value 2, value 3, goes on, semicolon. Now, let's see an example. Before we insert values in a table. At first, we have to create a database, then create a table and finally insert values. Already, we have learnt these commands in the previous video DDL Commands. Now, look at the screen. The database in which we are going to work with is opened at first, as we have created earlier. So, come on, look at the yellow box. We have to type show databases semicolon to view all the databases which we have stored already. We can type either in uppercase or lowercase, as MySQL is not case sensitive. What can you see here? There are many inbuilt databases already stored in MySQL. So, we are going to use the database, which we have created, named Institute. Yes, look at the red arrow pointing to Database Institute. So, what statement should we type now to use the Institute database? Look at the blue box below. We type the statement use Institute semicolon. Yes, the database is open now and we can use it. Inside the Institute database, we are creating a table named Student. Come on, look at the yellow box. Create table student open brackets roll number integer not null primary key comma, name varchar of 25 not null comma, gender char of 1 comma, marks integer of 10 comma, dob date close brackets semicolon. Now, look at the blue box below, we type show tables semicolon to verify that the table has been created in the Database Institute. Yes, now, look at the red arrow. You can see the student table in the Database Institute. Tables underscore and underscore institute means the Database Institute holds the table named student. Come on, now, we are going to insert values in the student table. Now, look at the yellow box. So in the MySQL prompt, we type the statement, insert into student values open brackets, 101, Kevin, M, 86, 2006-11-14 close brackets semicolon. So, to view the value in the table, look at the blue box. Type select star from student semicolon. Yes, what is displayed here? Look at the red box, we can see the first record entered in the table student displayed here. Like this you can insert many records in the table using insert into command. While inserting a row, if we are adding value for all the columns of the table, we need not specify the column's name in the SQL query. But we need to make sure that the order of the values is in the same order as the columns represented in the structure of the table. Let's learn some key points to remember. When values are inputted using insert into command, it is termed as single row insert value since it adds one tuple at a time into the table. The into clause specifies the target table and the values clause specifies the data to be added to the new record of the table. The argument or values of character or text and date data type are always enclosed in double or single quotation marks. Column values for the date data type of a column are provided within single quotes in YYYY-MM-DD or YYYY/MM/DD format. Null values are stored and displayed as null only without any quotes. If the data is not available for all the columns, then the column list must be included following the table name. The second form specifies both the column names and associated values to be inserted. The syntax is insert into table underscore name open brackets, column 1, column 2, column n, and so on close brackets, values, open brackets, value 1, value 2, value n, and so on, close brackets semicolon. Here column 1, column 2, column n, are the names of the columns in the table for which you want to insert data. Now, let's see an example. Look at the yellow box, we type the statement, insert into student open brackets, roll number name gender, marks, dob close brackets, values, open brackets, 102 Emeka F 92 2007-05-04 close brackets semicolon. Now, look at the blue box, we type select star from student semicolon to view the table values. Yes, look at the red box, you can see the record of Emeka holding roll number 102 is displayed in the table student. Let's learn the third form, inserting data into specific columns of a table. It inserts values for specific columns of a table. The syntax is, insert into table underscore name open brackets, column 1, column 2, column n, and so on close brackets, values, open brackets, value 1, value 2, value n, and so on, close brackets semicolon. Let's see an example. Now, look at the yellow box. Now we type the statement, insert into student open brackets, roll number name marks close brackets values open brackets, 103 Sam 75, close brackets, semicolon. So, here, we have inserted values for specific columns of a student table. Like roll number, name and marks. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see in the red boxes? Null. So, this statement shall insert the values for specific columns like roll number, name and marks respectively. Also, the columns gender and DOB shall hold the values as null. Let's learn how to insert null values into a table. So, what is a null value? When a column in a row has no value or is missing data, it's termed as holding a null value. Permissible columns. Null values can be assigned to any column except when it's the primary key or has a not null constraint. Usage of null. It's advisable to use null when the actual value is undefined or unavailable. Different treatment. Null values differ from other values as they represent missing or unknown data. Default capability. By default, columns in a table can store null values. Optional columns. For optional columns, records can be inserted or modified without providing values, storing them as null. Inserting null. You can insert a null value into any column by using the term null without quotes. Null versus zero. Null is not equivalent to zero, it serves as a placeholder for unknown or inapplicable values. Let's see an example. Now, look at the yellow box. Now we type the statement, insert into student open brackets, roll no comma, name comma, gender comma, marks comma, DOB, close brackets, values open brackets, 104 comma, David comma, M, comma, null close brackets, semicolon. So, we have typed null values for marks and DOB. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see in the red boxes? Null. Null values shall be inserted for the fields marks and DOB respectively. Let's learn how to modify data in a table. To modify data within a table and alter values in existing records, we use the update statement. The syntax is, update table underscore name set column 1 equals value 1 comma, column 2 equals value 2 comma and goes on, where condition semicolon. Syntax involves specifying the table to update and using the set keyword to assign new values. Where clause specifies which rows to modify, restricting updates to certain conditions. New data assignment, the set keyword assigns the new data to the respective columns. Selective modification, where clause filters the rows to be updated, affecting only those that meet the specified conditions. Let's see an example. Now, look at the yellow box. Now we type the statement, update student set marks equals 88 where roll number equals 101 semicolon. Where roll number equals 101. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see? Yes, the marks of Kevin with roll number 101 is updated from 86 to 88. Here, you can see the updation clearly, the marks of Kevin with roll number 101 is updated from 86 to 88. Let's learn how to update multiple columns. Modifying the values in more than one column can be done by separating the columns along with the new values using set clause, separated by commas. Let's see an example. Look at the yellow box. We type the statement, update student, set marks equals 95, DOB equals 2007-10-04, where name equals Emeka. So, here we are updating multiple columns, marks and DOB. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see? Yes, we can see the marks of Emeka updated from 92 to 95 and DOB, 2007-05-04, has updated to 2007-10-04. So multiple columns can be updated. Now, you can see the updation here. We can see the marks of Emeka updated from 92 to 95 and DOB, 2007-05-04, has updated to 2007-10-04. So multiple columns can be updated. Let's learn how to update using an expression or formula. Let's see an example. Look at the yellow box. We type the statement, update student, set marks equals marks plus 1, where roll number equals 101 or roll number equals 103 semicolon. So for roll number 101 and 103, we update mark equals mark plus 1. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see? Yes, we can see the marks updated by 1, for both roll number 101 and 103, so, mark 88 for roll number 101 updated to marks 89, and marks 75 for roll number 103 updated to marks 76. Now, you can see the updation here. Yes, we can see the marks updated by 1, for both roll number 101 and 103. So, mark 88 for roll number 101 updated to marks 89, and marks 75 for roll number 103 updated to marks 76. So, the update statement shall increment the value of marks by 1 for the records 101 and 103 respectively. Let's learn how to update all rows using an expression or formula. Let's see an example. Look at the yellow box. We type the statement, update student, set marks equals marks plus 2 semicolon. We didn't mention any where clause here. No condition is given. That means it updated all rows of the table student. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see? Yes, we can see that the update statement shall increase the value of marks of all the students by 2. So, marks of roll number 101 has updated from 89 to 91 marks. Marks of roll number 102 has updated from 95 to 97 marks. And marks of roll number 103 has updated from 76 to 78 marks. Now, you can see the updation here. Yes, we can see that the update statement shall increase the value of marks of all the students by 2. So, marks of roll number 101 has updated from 89 to 91 marks. Marks of roll number 102 has updated from 95 to 97 marks. And marks of roll number 103 has updated from 76 to 78 marks. Let's learn how to update to null values. The values for the attributes in a relation can also be entered as null using update command. Let's see an example. Look at the yellow box. We type the statement, update student, set marks equals null, where roll number equals 103 semicolon. We are updating marks of roll number 103 to null values. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see? Yes, we can see the update statement shall change the value of the field marks to null for the student whose roll number is 103. Now, you can see the updation here. Yes, we can see the update statement shall change the value of the field marks to null for the student whose roll number is 103. Mark 78 of roll number 103 is updated to null value. Let's learn about removing data from a table. The delete statement is used to delete rows from a table. The syntax is delete from table underscore name where condition semicolon. Here, table underscore name is the table whose records are to be deleted. Note that the where clause in the SQL delete command is optional and it identifies the rows in the column that get deleted. If you do not include the where clause, all the rows in the table are deleted. Let's see an example. Look at the yellow box. We type the statement, delete from student where roll number equals 104 semicolon. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see? Yes, we can see roll number 104 record is deleted, and 3 rows in set. So, the update statement shall delete the record only for roll number 104. Yes, we can see roll number 104 record is deleted, and 3 rows in set. So, the update statement shall delete the record only for roll number 104. To delete all the rows from the student table, look at the yellow box. We type the statement, delete from student semicolon. Now, look at the blue box. We type the statement, select star from student semicolon. Now, what can you see? Yes, we can see empty set. Note that all records in the table student is deleted, but it does not free the space containing the table. Let's learn about the truncate statement. Truncate statement is used to delete all the rows from the table and free the space containing the table. The syntax is truncate table underscore name semicolon. Example, truncate table student semicolon. Let's learn the difference between delete and truncate statement. Function. Delete statement removes specific rows based on conditions or all rows, whereas truncate statement removes all rows from a table. Granularity. In delete statement, there is selective deletion with where clause, whereas in truncate statement, it deletes all rows, no where clause used. Transaction impact. Delete statement can be rolled back using transaction log, it's a DML operation. What do you mean by rolled back? Let's see an example. Let's say a transaction involves updating multiple rows in a table. If an error occurs halfway through the transaction, a rollback command can be issued. This action will undo all the changes made by that incomplete transaction, effectively bringing the database back to its state before the transaction began. Now, in truncate statement, it cannot be rolled back, it's a DDL operation. Performance. Delete statement, generally slower due to individual row deletions, but it does not free the space containing the table. Whereas truncate statement, typically faster as it deallocates data pages, frees the space containing the table. I hope you've understood it properly. Remember, the key to mastering DML commands is consistent practice and a hands-on approach. The more you work with these commands and understand how they interact with the database, the more proficient you'll become. MySQL DQL Commands. Now in this video, we are going to learn about Data Query Language, DQL, commands, which includes select command. Let's learn about SQL query processing. Now look at the steps. Step 1, creating the database. Step 2, creating the table. Step 3, inserting the data in the table. Data is stored in the table. Now, it's time to perform Step 4, query processing on the already created tables to retrieve and view the data on the screen. So, what is a query? A query is a command given to get a desired result from the database table. The select command is used to query or retrieve data from a table in the database. SQL select statement is used to fetch data from one or more database tables. It is used to select rows or columns from a database or relation. Let's learn about SQL select statement. Select statement is used to retrieve data from a database. It is the most commonly used SQL command. It can be used to retrieve a subset of rows or columns from one or more tables present in a database. Here, we are going to discuss about projection using select command, selection, selecting specific rows using where clause, reordering columns while displaying query results, eliminating duplicate or redundant data using distinct clause. Let's discuss about the projection using select command. So what do you mean by projection? Projection involves selecting specific columns from a table while retrieving data. It's achieved by listing the desired column names after the select keyword. It returns all rows from a relation with selective attributes. It displays all columns along with the respective rows. The syntax is select column underscore name 1, column underscore name 2, and goes on, from table underscore name semicolon. Here, column underscore name 1, column underscore name 2, are the field names of the table you want to select data from. The table underscore name represents the name of the table you want to select data from. Let's see an example. Before you start using select for DQL, make sure you're familiar with and have worked on DDL and DML statements. Before we start query processing using select command, at first, we have to create a database, then create a table and insert values in the table. Now, look at the screen. The database in which we are going to work with is opened at first, as we have created the database earlier. So, come on, look at the yellow box. We have to type show databases semicolon to view all the databases which we have stored already. We can type either in uppercase or lowercase, as MySQL is not case sensitive. What can you see here? There are many inbuilt databases already stored in MySQL. So, we are going to use the database, which we have created, named Institute. Yes, look at the red arrow pointing to Database Institute. So, what statement should we type now to use the Institute database? Look at the blue box below. We type the statement use Institute semicolon. Yes, the database is open now and we can use it. Inside the Institute database, we are creating a table named Student Info. Come on, look at the yellow box. In the MySQL prompt, we type the statement, create table student info, open brackets roll number integer not null primary key, name varchar of 25 not null, gender char of 1, marks integer of 10, dob date, stream varchar of 25, close brackets semicolon. Now, look at the blue box below. In the MySQL prompt, we type the statement, show tables semicolon to verify that the table student info has been created in the Database Institute. Now, press the enter key. Yes, now, look at the red arrow. You can see the student info table in the Database Institute. Whatever tables you have created earlier in the Database Institute will be displayed here, as we have typed, show tables in the MySQL prompt. All the tables will be shown under the Database Institute. Now, we are going to use table student info inside the Database Institute. Come on, now, we are going to insert values in the student info table. Now, look at the yellow box. We have used insert into values command to insert 10 records in the student info table. You can add any number of records, as shown on the screen. Yes, we have inserted 10 records. Now what's next? Step 4. We have to start query processing. Projection of SQL returns all rows from a relation with selective attributes or columns. Let's see an example. Now, look at the yellow box. In the MySQL prompt, we type the statement, select name, gender from student info semicolon. And when pressed enter key. What can you see here? Yes, look at the red box. This select command displays only name and gender attributes from the student info table containing 10 rows or records. Projection of SQL displays all columns along with the respective rows. Look at the yellow box. We type the statement, select star from student info semicolon. Press the enter key. What can you see? Yes, look at the red box. It displays all the rows of all the columns according to the column list defined in the table structure student info. You have to note that the asterisk star symbol means all. Select asterisk or select star means displaying all the columns from a relation. Let's see salient features of SQL select statement. Column order display. Select command displays the columns of the table in the same order in which they are selected from the table. Asterisk for all columns. To retrieve all the columns in the column list from a table using select command, asterisk, star symbol, is used and the columns are displayed in the same order in which they are stored in the table. Semicolon termination. All the statements, inclusive of select statement, in SQL are terminated with a semicolon. Use of semicolon is dependent on the version in use. Let's learn about selection, selecting specific rows using where clause. Partial rows, all columns. It returns some of the rows and all the columns in the relation. Where clause for specific tuples. Use of where clause is required when specific tuples are to be fetched or manipulated. Asterisk for all columns. To select all the columns from a table, the asterisk, that is star symbol, can be used. Where clause evaluation. When a where clause is used with a select statement, the SQL query processor scans the entire table row by row. It checks each row against the condition specified in the where clause. If the condition is true for a row, that row is selected and displayed. Otherwise, if the condition is false for all rows, it returns an empty set, no data found. Let's see an example. Now, look at the yellow box. In the MySQL prompt, we type the statement, select star from student info where gender equal to m semicolon. Press enter key. What is seen here? Yes, look at the red box. It displays all attributes or columns but specific tuples, rows, which satisfy the condition in the student info table. So, all the records or rows of gender equal to m, totally 5 rows, are selected and printed. Let's see another example. Now, look at the yellow box. In the MySQL prompt, we type the statement, select star from student info where roll number less than or equal to 106 semicolon. Press the enter key. What can you see here? Yes, look at the red box. It displays only those records whose roll number is less than or equal to 106. So totally 6 rows are selected and printed. Let's learn about reordering columns while displaying query results. Column order customization. Query results can have their column order adjusted as per user preference during display. Display modification only. This reordering is solely for presentation purposes, not changing the physical arrangement or storage of columns in the database. User-friendly presentation. Users can alter column sequence in query outputs for better readability without affecting the database's actual structure. Let's see an example. Now, look at the yellow box. In the MySQL prompt, we type the statement, select name, roll number, DOB, marks from student info semicolon. Press enter key. What can you see here? Yes, look at the red box. The column shall be displayed in the changed order as name shall be displayed as the first column, roll number as the second column, DOB as the third column and marks as the fourth column respectively. 10 rows are selected and printed. Let's learn about eliminating duplicate or redundant data using distinct clause. Duplicate row removal. Distinct in a select statement eliminates duplicate rows from the query results, displaying each unique row once. Unique column values. It's utilized to fetch exclusively distinct or unique values from a specific column within the table. Single usage. The distinct keyword can be applied only once in a single select statement, ensuring uniqueness based on the entire row retrieved or on specific columns. The syntax is, select distinct column _name from table _name semicolon. Let's see an example. Now, look at the yellow box. In the MySQL prompt, we type the statement, select stream from student info semicolon. What can you see in the display of the blue box? Yes, this statement shall return all the tuples for field stream from table student info. It will return duplicate values also. That is the repeated values. Science stream is displayed 4 times, vocational stream is displayed 2 times, commerce stream is repeated 2 times and so on. Thus, in order to remove these duplicate values, distinct clause is used. Now, we write a query for displaying the distinct contents on the basis of the field stream from student info table. Now look at the red box. In the MySQL prompt, we type the statement, select distinct stream from student info semicolon. Press the enter key. What can you see in the display of the pink box? Yes, each stream like science, vocational, commerce and humanities is selected only once. Duplicate values are removed. MySQL operators explained. Let's learn about SQL operators. While working with select statement using where clause, condition-based query can be carried out using 4 types of SQL operators: arithmetic operators, relational operators, logical operators, and special operators. Let's discuss one by one in detail. Let's learn about arithmetic operators. Arithmetic operators are used to perform simple arithmetic operations like addition, subtraction, multiplication, division, and modulus. These operators are used with conditional expressions and for performing simple mathematical calculations. For example, look at the red box. In the MySQL prompt, we type the statement, select 6 plus 4 from dual semicolon. Answer is 10. Look at the yellow box, select 40 minus 20 from dual semicolon. Answer is 20. Look at the blue box, select 8 asterisk 8 from dual semicolon. Answer is 64. Look at the green box. Select 32/5 from dual semicolon. Answer is 6.4000. Look at the pink box. Select 32 mod 5 from dual semicolon. The modulus operator returns the remainder as the answer after performing the division operation. Hence it returns the value 2 as the output. So what do you see from these statements? Yes, dual. What's that dual? Dual is the default table automatically created in MySQL. It has one row with a value x, and one column dummy defined as varchar2 of 1. Dual is purely for the convenience of people who require that all select statements should have from and possibly other clauses. MySQL may ignore the clauses. MySQL does not require from dual if no tables are referenced. Meanwhile, you are permitted to specify dual as a dummy table name in situations where no tables are referenced. Now look at the last brown box. In MySQL, we can also type the statement select 6 plus 4 semicolon. Without writing from dual. This will also give the same number 10 as output. Evaluating scalar expressions with select statement. Calculation within columns. MySQL allows calculations on column contents using the select statement. Scalar expressions. It supports writing scalar expressions and using constant values for selected columns. Handling null values. When using null values in expressions, the result will be null. Arithmetic operators. Arithmetic operators, addition, subtraction, multiplication, division, can be used in evaluating scalar expressions alongside null values. Let's see an example. Do you remember these steps? Create database, create table, insert values in the table, and finally query processing. Yes, at first, let's open the database. Now, look at the yellow box on the screen. We type the statement, show databases semicolon. Look at the red arrow, we are going to use Database Institute. So what should we type next? Look at the blue box, type, use institute semicolon, to use the Database Institute. Look at the blue box. We type the statement, show tables semicolon. We can see the table names as seen here. We are going to use student info table. Look at the blue box. We type the statement, select star from student info semicolon. When we press enter key on the computer, we get the following display. Look at the yellow box. This is the table we have already created. It contains 10 records. This is the student info table, which we are going to use throughout this video for reference. Now let's see an example for evaluating scalar expression with select statement. Look at the blue box. We type the statement, select roll number, name, marks plus 2 from student info semicolon. Press enter key. What's on the display? Look at the red box. The above statement on execution shall increment the value for all the rows of the field marks by 2 and shall display the roll number, name and marks for all 10 students, increased by 2. You can compare the marks of the original student info table and the same table updated with marks plus 2 for all the students of 10 records. So, Rian's marks 80 becomes 82, Peter's marks 75 becomes 77, and so on, increment by 2 for all 10 students. Let's learn about the relational operators. Relational or comparison operators are mathematical symbols used to compare two values. They work with values of the same or compatible data types. Comparison operators evaluate conditions, resulting in a Boolean outcome, true or false, based on the comparison. These operators are commonly used with the where clause in SQL queries to filter data based on specified conditions. You can recall the relational operators given in the table. Equal to, greater than, less than, greater than equal to, less than equal to, not equal to. Let's see an example. Look at the blue box. We type the statement, select roll number, comma, name, comma, marks from student info where marks greater than equal to 90 semicolon. When you press the enter key, what will be the display? Yes, look at the purple box. The statement shall display the roll number, name and marks of all the students with marks either equal to or greater than 90. Here, marks of Emeka and Nancy are either equal to or greater than 90. And hence their record with roll number, name and marks are displayed. Below yellow table is the original student info table for your reference. Totally we have 10 rows or records. For each example, I show this original student info table for your reference. So you can easily find the changes happening in each statement. Let's see another example. Look at the blue box. We type the statement, select star from student info where stream not equal to vocational semicolon. Press enter key. What will be the display? Yes, look at the purple box. This statement shall display the records of all the students who are not from vocational stream. So 8 rows are selected. The vocational stream is left. Below yellow box is for your reference, which is the original student info table containing 10 rows or records. Thus, while using relational operators in a where clause with a select statement, the database program goes through the entire table checking each record one by one and compares with the conditions specified. If it is true, the corresponding row is selected for display, otherwise it is ignored. While comparing character, date and time using relational operators, it should be enclosed in single quotation marks. Let's learn about the logical operator. The purpose of SQL logical operators are the operators used to combine multiple conditions in SQL statements to filter data. Logical operators are also known as Boolean operators. Operators. 3 main logical operators are and, or, not. The and operator requires all conditions to be true for a record to be selected. The or operator selects a record if any of the conditions are true. The not operator reverses the truth value of the condition, negation. Functionality. And operator narrows down data by combining multiple conditions that all need to be true. Or operator expands the selection by including records that meet at least one of the conditions. Usage. It helps in creating more complex and specific queries by specifying multiple conditions for data retrieval. In SQL, the order of precedence for logical operators is not and then or. So, when multiple logical operators are used in a single statement, not will be evaluated first, followed by and finally or. This determines how the conditions are evaluated and combined within the SQL query. The and operator. The and operator in SQL displays a record if all specified conditions in the where clause are true. As shown in the table, when both condition 1 and condition 2 are true, then only is the result true. If either of them is false, the result becomes false. Let's see an example. Look at the blue box. We type the statement, select star from student info where marks greater than 80 and gender equal to M semicolon. Press enter key. What will be the display? Yes, look at the purple box. This statement lists the details of all the students who have secured more than 80 marks and are male. Here, 2 records, Daniel and Jack, are selected from the student info table, which satisfies both condition marks greater than 80 and gender is male. Yellow box holds the original student info table for your reference. Next is the or operator. The or operator in SQL displays a record if at least one specified condition in the where clause is true. As shown in the table, when either condition 1 or condition 2 is true, the result is true. If both of them are false, then only the result becomes false. Let's see an example. Look at the blue box. We type the statement, select roll number, comma, name, comma, stream from student info where stream equals science or stream equals commerce semicolon. Press enter key. What will be the display? Yes, look at the purple box. This statement displays the roll number, name and stream of all the students who are in either science or commerce stream. Here 6 rows or records are selected whose streams are either science or commerce. The original student info table enclosed in the yellow box is for your reference. The not operator in SQL negates a single condition, returning the opposite truth value. It flips true to false and false to true for the specified condition in the where clause. If condition 1 is true, result is false, and condition 1 is false, the result is true. Let's see an example. Look at the blue box. We type the statement, select name, marks from student info where not, stream equals vocational, semicolon. Press enter key. What will be the display? Yes, look at the purple box. The statement displays the name and marks of all the students who are not in the vocational stream. Totally 8 rows or records are displayed. The original student info table enclosed in the yellow box is for your reference. Let's learn about special operators in SQL that perform special functions. Conditions based on a range, between, and. Not between, and. Conditions based on a list, in, not in. Conditions based on pattern, like, not like. Conditions based on a range, between, and. The between and operator in MySQL is used to check if a value falls within a specified range. The range includes both the lower and upper value. The values can be numbers, text, or dates. Let's see an example. Now, look at the blue box. In the MySQL prompt, we type the statement, select roll number, name, marks from student info where marks between 80 and 100 semicolon. Press Enter key. What will be the display? Yes, look at the purple box. This command displays roll number, name along with marks of these students whose marks lie in the range of 80 to 100, both 80 and 100 are included in the range. Totally 7 records are displayed. The original student info table enclosed in the yellow box is for your reference. Conditions based on a range, not between. Not between operator in MySQL is used to check if a value is outside that range. It is opposite to the between operator. Let's see an example. Look at the blue box. We type the statement, select roll number, name, marks from student info where marks not between 80 and 100 semicolon. Press Enter key. What will be the display? Yes, now, look at the purple box. It retrieves the rows which do not satisfy the between condition. So, the roll number, name and marks of all the students which is not between 80 and 100 are displayed. Here 3 records are displayed. The original student info table enclosed in the yellow box is for your reference. Next, we discuss about the conditions based on a list, in operator. The in operator in MySQL allows you to specify multiple values within parentheses. It checks whether a specified value matches any value in a list. Let's see an example. The syntax is select column underscore names from table underscore name where column underscore name in open parentheses, value 1, value 2, goes on, close parentheses, semicolon. Let's see an example. Look at the blue box. We type the statement, select star from student info where stream in, science, commerce, humanities, semicolon. Press Enter key. What will be the display? Yes, now look at the purple box. The above command displays all those records whose stream is either science or commerce or humanities. Here, 8 records are displayed. The original student info table enclosed in the yellow box is for your reference. Conditions based on a list. Not in operator. The not in operator is the negation of the in operator. It checks whether a specified value does not match any value in a list. Let's see an example. Look at the blue box. We type the statement, select star from student info where stream not in open parentheses, science, commerce, humanities, semicolon. Press Enter key. What will be the display? Yes, look at the purple box. The above command returns the rows that do not match the list, science, commerce and humanities and hence vocational stream list is displayed. 2 rows are displayed. The original student info table enclosed in the yellow box is for your reference. Conditions based on pattern. Let's discuss about the like operator. The like operator is used to match a specified pattern within a column's data. This operator is used with the columns of type char and varchar. The like operator searches the column to find if a part of this column matches the string specified in the parentheses after the like operator in the command. Let's discuss about the wildcard characters. The SQL like condition allows us to use wildcards to perform pattern matching. SQL provides 2 wildcard characters that are used while comparing the strings with like operator. % matches any sequence of characters, 0 or more characters. Underscore matches any single character. The syntax is select column underscore names from table underscore name where column underscore name like pattern semicolon. Let's see an example. Look at the blue box. We type the statement, select star from student info where name like %, semicolon. Press Enter key. What will be the display? Yes, now, look at the purple box. The above command shall display those records where the name begins with the character E. Here, we find one record named Emika, beginning with E. The original student info table enclosed in the yellow box is for your reference. Let's see another example. Look at the blue box. We type the statement, select star from student info where name like %L semicolon. Press Enter key. What will be the display? Yes, now, look at the purple box. The above command shall display the records for those students whose name ends with the letter L. Here two records, Daniel and Rachel, ends with letter L. The original student info table enclosed in the yellow box is for your reference. Let's see another example. Look at the blue box. We type the statement, select star from student info where name like underscore, a, %, Press enter key. What will be the display? Now, look at the purple box. The above command shall display all the students whose name contains the letter A at the second place. Here, for records Daniel, Rachel, Nancy, Jack, contains the second letter A, are displayed. The original student info table enclosed in the yellow box is for your reference. Let's discuss about the conditions based on pattern. Not like. The not like operator works opposite to like operator. It returns the rows that do not match the specified pattern. Let's see an example. Look at the blue box. We type the statement, select star from student info where name not like %I, __, Press enter key. What will be the display? Now, look at the blue box. The above command shall display all the students whose name does not contain the letter I from the third last position. Student Emeka and Daniel has the letter I from the third last position. So, they are not displayed as they do not match the specified pattern. Remaining 8 records are displayed. The original student info table enclosed in the yellow box is for your reference. MySQL comments, aliases, sorting. Comments in SQL or MySQL. The purpose of comments. SQL comments serve as documentation within the code and are ignored during execution. Functionality clarification. Comments in SQL explain what different parts of the code do without getting into all the detailed steps. Enhanced readability. Comments improve code readability and maintenance, making applications easier to understand and modify. Placement. Comments can be inserted between keywords, parameters, or punctuation marks in a statement. Types of comments. SQL supports both single-line and multiple-line comments for annotating code. Let's see an example to understand better. Before that, we will move on to the comment styles used in SQL. 3 comment styles of SQL or MySQL are: first comment style is comments beginning with 2 dash lines, followed by a space. In SQL statements, double dash lines, like this, indicate single-line comments. These comments are used to annotate code and explain the program's flow. They are placed at the beginning or end of a program to offer insights for users. Single-line comments in SQL cannot extend to new lines and terminate with a line break. Next comment style is comments beginning with hash symbol. The comments begin with hash symbol followed by the text to be displayed for the user's information. This text cannot extend to a new line and ends with a line break. Next comment style is comments beginning with slash and an asterisk. Multi-line comments begin with a slash and an asterisk, followed by the text of the comment. This text can span multiple lines. The comment ends with an asterisk and a slash. The opening and terminating characters need not be separated from the text by a space or a line break. Let's see an example. Look at the blue box. In the MySQL prompt, we type the statement, select role no comma, name comma, stream. Now, look at the second line. We use the comment style /*, marked in yellow box for your reference, and we write the comment text inside. Let's read the statement. This statement shall display the records of all those students. Now I want the remaining statement in the next line, so I press the enter key. Third line starts now. Now look at the third line. It automatically took the same comment style /* in the front, which is underlined in yellow for your reference. You can see it before the arrow. Now we continue the line statement, who are in science stream and have secured marks more than 80. And now we have to end the comment style as asterisk and a slash. Again marked in yellow box for your reference. We already learned that multi-line comments begin with a slash and an asterisk, followed by the text of the comment. And this is the best example. Now come to the fourth line. From student info, hashtag, student info table in use. Hashtag is in green box, given for your reference. Hashtag is used to display users' information. This text cannot extend to a new line and ends with a line break. Now look at the last line, where stream equals science and marks greater than 80 semicolon, double dash line condition for selection. Double dash line is given in pink box for your reference. You can see the double dash lines, which indicate single line comments. These comments are used to annotate code and explain the program's flow. They are placed at the beginning or end of a program to offer insights for users. Here, it is placed at the end of the program. Let's look at the output. Now, look at the red box below. The output doesn't show any comment statement. Just gives only the output for the above code. Do you remember the purpose of the comments in SQL? SQL comments serve as documentation within the code and are ignored during execution. So, after executing the code, comments are ignored in the output. SQL aliases are temporary names assigned to columns or tables within a query. Aliases are often used to make column names more readable. When using aliases in SQL, renaming columns or tables with aliases does not change their actual names or modify the underlying database structure. An alias only exists for the duration of that query. An alias is created with the as keyword. Aliases can be used when more than one table is involved in a query, functions are used in the query, column names are big or not very readable, two or more columns are combined together. Column aliases are used to rename columns in the result set of a query. Using column alias name, we can give different names to columns for display, output, purpose only. They are created to make column names more readable. The syntax is, select column name as alias underscore name, from table underscore name, where, condition, semicolon. Here, column name is the fields in the table. Alias underscore name is the temporary alias name to be used in replacement of original column name. Table underscore name is the name of table and condition represents the expression that defines the criteria for selecting rows. Let's see some examples. Example 1, column alias. To fetch name and DOB from the student info table using student underscore name and date underscore of underscore birth as an alias name. Let's open the database which we have already created. Now, look at the blue box. In the MySQL prompt we type show databases semicolon. Press enter key. What will be the display? Yes, look at the yellow box. All the databases are displayed. We are going to use Institute database. Now, look at the pink box. We type use Institute semicolon. Press enter key. Now, Database Institute is opened. Now look at the green box. We type show tables semicolon. When pressed enter key. Look at the red box. Two tables are displayed under Database Institute. We are going to use the table student info. Now look at the blue box. We type the statement select star from student info semicolon. Press enter key. Now, look at the yellow box. We find the display of the student info table with all the details containing 10 records. Now we are going to use column alias. Remember the example 1. Column alias. To fetch name and DOB from the student info table using student underscore name and date underscore of underscore birth as an alias name. Now, look at the blue box. We type the statement select name as student underscore name comma, DOB as date underscore of underscore birth from student info semicolon. When pressed enter key. What is the display seen here? Yes, look at the yellow box. The column name is changed as student underscore name and column name DOB is changed as date underscore of underscore birth. Let's learn about table aliases. Table aliases are used to provide temporary names to tables in a query, especially when dealing with multiple tables. The syntax is select column name 1, column name 2, and so on, from table underscore name as alias underscore name where, condition, semicolon. Here, column name 1, column name 2 are the fields in the table. Table underscore name is the name of table. Alias underscore name is the temporary alias name to be used in replacement of original table name. Let's see an example of table aliases, which are used to provide temporary names to tables in a query, especially when dealing with multiple tables. First, look at the red box. We type the statement, create database customer order DB semicolon. And press enter key. Database is created. Now, look at the blue box. We type the statement show databases semicolon. Press enter key. What can you see? Yes, all the databases stored in the system is displayed. We can also see the database customer order DB. Now let's create two tables customers and orders and insert values. At first let's create the customers table. Now, look at the red box. Before creating the table, we should use the database where we are going to store the customers table. So we type the statement, use customer order DB semicolon. Database is changed. Now, look at the blue box. We type the statement, create table customers, open brackets, customer underscore ID into primary key comma, customer underscore name varchar of 100, comma, email varchar of 100, comma, phone underscore number varchar of 20, close brackets, semicolon. When pressed enter key. Table customers is created. Now let's insert values into the customers table. Look at the red box. We use the statement insert into customers, customer underscore ID, customer underscore name, email, phone underscore number, values. We type the data for 5 records, as shown here. Now to view the table customers, look at the blue box. We type the statement, select star from customers semicolon. When pressed enter key, we get the table displayed here with 5 records. Secondly, we create the orders table. Now, look at the red box. Before creating the orders table, we should use the database where we are going to store the orders table. So we type the statement, use customer order DB semicolon. Database is changed. Now, look at the blue box. We type the statement, create table orders, open brackets, order underscore ID int primary key comma, customer underscore ID int comma, order underscore date comma, total underscore amount decimal, 10 comma, 2, close brackets, semicolon. When pressed enter key, orders table is created. Now, we insert values in the orders table. Look at the red box. We type the statement, insert into orders, open brackets, order underscore ID comma, customer underscore ID comma, order underscore date comma, total underscore amount, close parentheses, values, and we insert datas for 5 records as shown here. Now to view the table orders, look at the blue box. We type the statement, select star from orders semicolon. When pressed enter key, we get the table displayed here with 5 records. Now is the time to use table aliases. Look at the red box. We type the statement, select o.order underscore ID comma, o.order underscore date comma, c.customer underscore name from orders o comma, customers c where o.customer underscore ID equals c.customer underscore ID and o.total underscore amount greater than 1000 semicolon. In this query, orders table is represented by the alias o, customers table is represented by the alias c. Now, look at the second line. The comma used in between orders o and customers c indicates that you're querying both tables. The where clause filters the results to only include orders where the total underscore amount is greater than 1000 and links the orders and customers tables based on the customer underscore ID. Now, let's look at the blue box for output. Only 3 records are displayed for the above query. Thus, table aliases are used to provide temporary names to tables in a query, especially when dealing with multiple tables. Alias name can be given to a mathematical expression also. Let's see an example. Look at the yellow box. In the MySQL prompt we type the statement, select 22/7 as pi semicolon. Now press enter key. What will be the display? Yes, look at the red box. The output displayed is the pi value 3.1429. Here are some key points to remember. If the alias underscore name contains spaces, you must enclose it in quotes. It is acceptable to use spaces when you are aliasing a column name. However, it is not generally a good practice to use spaces when you are aliasing a table name. The alias underscore name is only valid within the scope of the SQL statement. Let's discuss how to put text in the query output. In order to get an organized output from a select query, we can include some user-defined columns at runtime. These columns are displayed with a valid text, symbols and comments in the output only. These included columns will appear as column heads along with the contents for that column. Let's see an example. Look at the blue box. To choose the database, we type the statement, show databases semicolon. When pressed enter key, all the databases in the system is displayed as shown here. Here we are going to use the Institute database. Now, look at the blue box. We type the statement, use Institute semicolon. Database is changed. Now, we want to know all the tables stored in the Institute database. Look at the yellow box. We type the statement show tables semicolon. When pressed enter key, we can view all the tables under the database Institute. Now we are going to choose the table student info. Look at the blue box. We type the statement, select star from student info semicolon, to view the data of the table. When pressed enter key. Look at the yellow box, you can see 10 records in student info table. Now, we are going to put text in the query output. Look at the blue box. We type the statement, select role no comma, name comma, open single quotes, was born on, close single quotes, comma, DOB from student info semicolon. When pressed enter key, what can you see? Yes, look at the yellow box, the above command on execution shall display the text, was born on, with every record or tuple of the table which is shown here in red box for your reference. Let's see, sorting in SQL using order by. The SQL order by clause is used to sort the data in ascending or descending order based on one or more columns. The order by keyword is used to sort the result set by one or more fields in a table. This clause sorts the records in ascending order, ASC, by default. In order to sort the records in descending order, DESC keyword is to be used. Sorting using order by clause can be done on multiple columns separated by comma. The syntax is select column list from table underscore name where, condition, order by column underscore name, ASC or DESC, semicolon. Here, where clause is optional. Let's see an example. Look at the blue box. We type the statement, select star from student info semicolon. When pressed enter key, we can see the table displayed here in yellow box, on the screen with 10 records. Now we are going to sort the records using order by. Let's see an example. To display the roll number, name and marks of students on the basis of their names in the ascending order. Look at the blue box. We type the statement, select roll no comma, name comma, marks from student info order by name semicolon. Now, look at the yellow box. We get the display of the roll number, name and marks of students on the basis of their names in the ascending order. So record Bob is displayed first, then Charlie, Daniel, Emeka, etc. You can view the original student info table on the green box, right side of the screen, for your reference. Let's see another example. To display the roll number, name and marks of students in descending order of their marks. Look at the blue box. We type the statement, select roll no comma, name comma, marks from student info order by marks DESC semicolon. When pressed enter key. Look at the display on the yellow box. Marks are displayed from 97 to 65 in descending order. You can view the original student info table on the green box, right side of the screen, for your reference. Let's see about sorting on column alias. If a column alias is defined for a column, it can be used for displaying rows in ascending or descending order using order by clause. Let's see an example. We type the statement, select roll no comma, name comma, marks as marks underscore obtained from student info order by marks underscore obtained semicolon. Here the column name marks uses an alias name marks underscore obtained and we are sorting by using the column alias, marks underscore obtained. Now look at the yellow box. The marks column is named as marks underscore obtained and the marks are displayed in ascending order from 65 to 97. Aggregate functions and null values. Until the previous video, we have learnt about single row functions which work in a single value. SQL also provides multiple row functions which work on multiple values. What are aggregate functions? In SQL, aggregate functions perform a calculation on multiple rows and return a single value. These functions are called aggregate functions or group functions. Aggregate functions is used with the group by and having clause in the select statement. Let's discuss about the various aggregate functions in SQL. The aggregate functions are maximum, minimum, sum, average, count, count star. Let's discuss about the maximum function. The max function is used to find the largest value in the given column or expression based on the column. It takes one argument which can be either a column name or any valid expression involving a particular column from the table. It can be applied on the numeric, character, or data values. The syntax is select max of column underscore name or expression from table underscore name semicolon. Let's see an example. Look at the blue box. In the MySQL prompt, we type the statement, select star from employee semicolon. Look at the yellow box. You can see 10 records holding employee number, name, salary, department, job and city. We are going to use the aggregate functions in these values. Now, we use the max function to find the largest value in the column salary. Look at the blue box. We type the statement, select max of salary from employee semicolon. Look at the yellow box. We get the maximum value 64,000. You can check the employee table in the green box for your reference. Let's discuss about the minimum function. The min function is used to find the lowest value in the given column or expression based on the column. It takes one argument which can be either a column name or any valid expression involving a particular column from the table. It can be applied on the numeric, character, or data values. The syntax is select min of column underscore name or expression from table underscore name semicolon. Let's see an example. Now, we use the min function to find the lowest value in the column salary. Look at the blue box. We type the statement, select min of salary from employee semicolon. Look at the yellow box. We get the minimum value 50,000. You can check the employee table in the green box for your reference. Here, 2 employees have the minimum salary 50,000. Let's discuss about the sum function. The sum function is used to find the total value of any column or expression based on a column. It accepts the entire range of values as an argument, which is to be summed up on the basis of a particular column, or an expression containing the column name. The sum function always takes argument of integer type only. Sums of string and date type data are not defined. The syntax is select sum of, all or distinct, column underscore name from table underscore name semicolon. The all keyword instructs the sum function to find the sum of all values while the distinct keyword forces the function to operate on distinct values only. It does not sum up the duplicate values. By default, the all option is used. Let's see an example. Now, we use the sum function to find the total value of 10 records from the column salary. Look at the blue box. We type the statement, select sum of salary from employee semicolon. Look at the yellow box. We get the sum value of all 10 records as 548,000.00. Here by default it calculates the total sum of 10 records of the salary amount. You need not mention all in the statement. You can check the employee table in the green box for your reference. Here, total of 10 employees' salary is calculated. Let's see another example of sum function with distinct keyword. The distinct keyword forces the function to operate on distinct values only. Duplicate values are not included. Look at the blue box. We type the statement. Select sum of distinctive salary from employee semicolon. Look at the yellow box. We get the sum value of all 8 records as 443,000.00. Look at the green box to view the table employee. Here look at the salary column. Salary amount 50,000.00 and 55,000.00 are repeated twice. Hence these values are duplicate values and are included only once and not twice. The average function is used to find the average of any column or expression based on a column. It accepts the entire range of values of a particular column to be taken average of, or even a valid expression based on this column name. The average function always takes argument of integer type only. Average of string and date type data are not defined. The syntax is select average of all or distinct of column underscore name from table underscore name semicolon. The all keyword instructs the average function to calculate the average of all values while the distinct keyword forces the function to operate on distinct values only. Duplicate values are not included. By default, the all option is used. Let's see an example. Now, we use the average function to find the average of 10 records from the column salary. Look at the blue box. We type the statement. Select average of salary from employee semicolon. Look at the yellow box. We get the average value of all 10 records as 54,800.00. Here by default it calculates the average of 10 records of the salary amount. You need not mention all in the statement. You can check the employee table in the green box for your reference. Here, average of 10 employees' salary is calculated. Let's see another example of average function with distinct keyword. The distinct keyword forces the function to operate on distinct values only. Duplicate values are not included. Look at the blue box. We type the statement. Select average of distinctive salary from employee semicolon. Look at the yellow box. We get the average value of all 8 records as 55,375.00. Look at the green box to view the table employee. Here look at the salary column. Salary amount 50,000.00 and 55,000.00 are repeated twice. Hence these values are duplicate values and are included only once and not twice. Next function is the count function. The count function is used to count the number of values in a column. It takes one argument which can be any column name or an expression based on a column. It returns the number of non-null values in that column. So what do you mean by non-null values? If a row in the column has a null value, it is not included in the count. This function is often used to find the number of records that have actual data in a particular column rather than being empty or having a null value. The syntax is select count of all or distinctive column or expression from table underscore name semicolon. Let's see an example. Now, we use the count function to count the number of values from the column salary. Look at the blue box. We type the statement. Select count of salary from employee semicolon. Look at the yellow box. We get the number of counts as 10. You can check the employee table in the green box for your reference. Here, counting the number of values in the column salary is 10. Let's see another example. Now, we use the count function to count the number of values from the column department. Look at the blue box. We type the statement. Select count of department from employee semicolon. Look at the yellow box. We get the number of counts as 8. You can check the employee table in the green box for your reference. In the department column we have 2 null values, which is not counted. Remember count function returns the number of non-null values in that column. So we get the non-null values as 8. Let's see another example. Now, we use the count function to count the number of values from the column job. Look at the blue box. We type the statement. Select count of job from employee semicolon. Look at the yellow box. We get the number of counts as 8. You can check the employee table in the green box for your reference. In the job column we have 2 null values, which is not counted. Remember count function returns the number of non-null values in that column. So we get the non-null values as 8. The next function is count star. The count star function counts the total number of records or rows satisfying the condition along with null values, if any, in the table. The syntax is select count of star from table underscore name semicolon. Let's see an example. Now, we use the count star function that counts the total number of records or rows satisfying the condition along with null values, if any, in the table. Look at the blue box. We type the statement. Select count of star from employee semicolon. Look at the yellow box. We get the number of counts as 10. So, the count star function on execution shall return the total number of records, including the null values and the duplicate values in the table employee. You can check the employee table in the green box for your reference. Let's learn about the aggregate functions and null values. You can see a table employee on the screen. Look at the salary field. There are some null values against the salary field for some employees. None of the aggregate functions takes null into consideration. Null values are simply ignored by all the aggregate functions. Let's see some examples. The employee table details are given in green box for your reference. Now, look at the yellow box. We are finding the lowest salary amount. Select min of salary from employee semicolon. We get the amount 20,000. So here null values are not considered. The employee table details are given in green box for your reference. Now, look at the yellow box. We are finding the largest salary amount. Select max of salary from employee semicolon. We get the amount 75,000. So here null values are ignored. The employee table details are given in green box for your reference. Now, look at the yellow box. We are counting the number of employees in the salary column. We type the statement, select count of salary from employee semicolon. We get 3 as output. Here, null values are ignored. The employee table details are given in green box for your reference. Now, look at the yellow box. We are calculating the average from the salary column. We type the statement, select AVG of salary from employee semicolon. We get 46,666.6667 as output. Look at the green box. It will be calculated as 75,000 plus 20,000 plus 45,000 divided by 3. That is, 140,000 divided by 3 is equal to 46,666.6667, that is, sum divided by the total number of records, which are 3, after ignoring null values. The employee table details are given in green box for your reference. Now, look at the yellow box. We are using the count star function in the table employee. We type the statement, select count of star from employee semicolon. We get 5 as output. The count of star function counts the total number of records or rows satisfying the condition along with null values, if any, in the table. Now, look at the yellow box. We type the statement, select count of a code from employee semicolon. We get 5 as output. No null value exists in the column a code. The employee table details are given in green box for your reference. You can check the code values which has no null values. Now, look at the yellow box. We type the statement, select count of salary from employee semicolon. We get 3 as output. Look at the green box. Null values are ignored while counting the total number of records on the basis of salary. So only 3 records are counted. Group by and having clause. Let's learn about the group by function. In SQL, the group by clause is used to arrange identical data into groups based on the values of one or more columns. It is often used in conjunction with aggregate functions, such as sum, count, average, max, or min, to perform operations on each group of data. The syntax is select column 1, column 2, up to column underscore n, aggregate underscore function of, expression, from table underscore name, where conditions, group by column 1, column 2, up to column underscore n, semicolon. Let's see an example. Let's use this table student info. The details of the 10 records are shown here having roll number, name, gender, marks, DOB and stream as column names. Now, we are going to use group by clause. Look at the blue box. We type the statement. Select name, stream, count of star as number of students, from student info, where marks greater than 85, group by name, stream, semicolon. Group by clause is used to arrange identical data into groups based on the values of one or more columns. So here, the data is grouped by name and stream. So the output will be 3 records, namely, Emeka, Daniel and Nancy are selected with marks above 85 and the number of students are 1 each. So here you can see the student info table, where Emeka, Daniel and Nancy have scored more than 85 marks, just for your reference. Let's discuss on having clause. The having clause in SQL is used in conjunction with the group by clause to filter the results of a query based on a specified condition for grouped rows. While the where clause filters individual rows before they are grouped, the having clause filters the results of aggregate functions applied to grouped rows. This is because the aggregate functions are not allowed to be used with where clause as it is evaluated on a single row, whereas the aggregate functions are evaluated on a group of rows. Thus, if any aggregate function is to be used after the from clause in a select command, then instead of using the where clause, having clause should be used. Note that the having clause was added to SQL because the where keyword cannot be used with aggregate functions. The syntax is select column 1, column 2, up to column underscore n, aggregate underscore function of, expression, from table underscore name, where condition, group by column 1, column 2, up to column underscore n, having, condition 1 up to condition underscore n, semicolon. Let's see an example. Select stream, sum of marks as total marks from student info, group by stream, having max of marks less than 85, semicolon. So here, we are selecting stream and sum of marks as total marks from the table student info, group by stream, having maximum marks less than 85. So the output is the sum of marks for vocational is 154 and sum of marks of humanities is 147. So here you can see the student info table, where the output is the sum of marks for vocational, highlighted here in yellow color is 75 plus 79 is 154 and sum of marks of humanities, highlighted here as red color, is 82 plus 65 is 147. As, we are selecting stream and sum of marks as total marks from the table student info, group by stream, having maximum marks less than 85. You may use any condition on group, if required having condition clause is used to apply a condition on a group. Let's see some examples. You can see a table named EMP containing 5 records with a code, name, salary, job and city as column names. Example 1. Look at the blue box. In the MySQL prompt, we type the statement, select city, sum of, salary. The select clause is used to specify the columns that will be included in the result set. In this case, it selects 2 columns, city and the sum of salary for each group of records. Next line, from EMP, the from clause specifies the table from which the data will be retrieved. In this query, the table is named EMP. Next line, group by city. The group by clause is used to group the rows in the result set based on the values in one or more columns. In this query, the data is grouped by the city column, which means that the subsequent aggregation functions will be applied separately for each unique city. Next line, having sum of salary greater than equal to 50,000. The having clause is used to filter the grouped results based on a specified condition. In this case, it filters the group's cities, where the sum of salaries in each group is greater than or equal to 50,000. So, in this query, we retrieve the total salary for each city from the EMP table, but only for those cities where the sum of salaries is equal to or exceeds 50,000. This is useful for finding cities with high total salaries among the employees. So you can see the output in the yellow box. New York City holds salary 50,000 plus 550,000 in total, sum 105000. And Los Angeles City holds salary 60,000 plus 55,000 in total, sum of salary 115000. Chicago City has 1 record and thus it holds 58,000. The green box is for your reference, which is the EMP table containing 5 records used for this query. Example 2. This SQL query is similar to example 1, but instead of using the sum function, it uses the AVG function to calculate the average salary for each city. Look at the blue box. We type the statement, select city, AVG of salary from EMP, group by city, having AVG of salary greater than equal to 50,000, semicolon. Look at the yellow box. You can see the average salary of New York City is 52,500. And Los Angeles is 57,500 and Chicago is 58,000. You can refer to the EMP table, which is on the green box. Let's see another example. Example 3. Look at the blue box. Look at the query. Let me explain now. Select city, min of salary, as min salary, max of salary, as max salary, sum of salary, as total salary specifies the columns you want to select in the output. It includes the city column, the minimum salary for each city as min salary, the maximum salary for each city as max salary, and the total salary for each city as total salary. Next line, from EMP, specifies the table from which to retrieve the data, in this case, the EMP table. Next line, group by city, groups the data by the city column. This means that the subsequent aggregate functions, min, max, sum, will be applied separately for each unique city. Next line, having total salary greater than equal to 55,000, filters the groups based on the condition that the total salary for each city must be greater than and equal to 55,000. Look at the yellow box for the output. The resulting output will show each unique city, the minimum salary for that city, the maximum salary for that city, and the total salary for that city, but only for cities where the total salary is greater than and equal to 55,000. The green box holds the EMP table details for your reference. Let's see another example. Example 4. Look at the blue box. In the MySQL prompt, we type the statement, select city, sum of salary, as total salary. This part of the query selects the column city and the total sum of salary for each unique city. Next line, from EMP, specifies the table from which the data is retrieved, in this case, the EMP table. Next line, where city equals Los Angeleses. This condition filters the rows to include only those where the city is Los Angeles. Next line, group by city, groups the results set by the city column. This means that the subsequent aggregation functions, like sum of salary, will be applied per unique city. Next line, having count of star less than equal to 2. This having clause filters the grouped results based on the count of rows in each group. It includes only those groups, cities, where the count of rows is less than or equal to 2. So, the final result of this query would be a list of cities where the city is Los Angeles, and the total count of rows for each city is less than or equal to 2, along with the total salary for each of these cities. Look at the yellow box. City Los Angeles has total salary $115,000, that is $60,000 plus $55,000. The green box holds the EMP table details for your reference. Let's learn about where versus having clause. Where clause works on individual rows of the whole table. It is used to filter rows based on conditions that apply to individual records. It's applied before any grouping or aggregation. Conditions are specified for each row in the table. Having clause. Having clause works on groups formed by the group by clause. It's used to filter groups based on aggregated conditions. It's applied after the group by clause and any aggregation functions, for example, sum, average. Conditions are specified for each group, not individual rows. Where and having clause. If both where and having are used in the same query, the where clause is executed first to filter individual rows based on specified conditions. After the where clause, the group by clause is applied, and then the having clause filters groups based on aggregated conditions. Where is used for row-level filtering, and having is used for group-level filtering. Aggregate functions and group by clause, other combinations. Null values are simply ignored by all the aggregate functions. An aggregate function may be applied on a column with distinct or asterisk, all, symbol. If nothing is given, all scope is assumed. You can see the employee table with null values against the salary field for some employees. None of the aggregate functions takes null into consideration. Null values are simply ignored by all the aggregate functions. Let's see some examples with sum function. Example 1. Sum function returns the sum of values in the given column or expression. Look at the blue box. In the MySQL prompt, we type the statement select sum of salary from employee semicolon. This query calculates the sum of the salary column for all rows in the employee table. Look at the yellow box for the output. The result shows that the total sum of salaries in the employee table is 140,000. That is 75,000 plus 20,000 plus 45,000. Null values in the salary column for the records with a code 2, Peter, and a code 4, Emily, are treated as 0. The green table below shows the details of the employee table for your reference. Example 2. You can see the green box below containing employee details of another database containing 10 records. Now, look at the blue box. We type the statement. Select sum of distinct salary from employee semicolon. This command calculates the sum of distinct salary values from the salary column in the employee table. The distinct keyword ensures that only unique salary values are considered in the summation. Look at the yellow box. The output indicates that the total sum of distinct salary values across all employees in the employee table is 443,000.00. Here, 50,000 and 55,000 are repeated and counted only once. The sum of distinct salary column represents the aggregated sum of unique salary values without counting duplicates. Example 3. You can see the green box below containing employee details of another database containing 10 records. Now, look at the blue box. We type the statement. Select sum of salary from employee where city equals Los Angeles semicolon. This command calculates the sum of the salary column for rows where the city column is equal to Los Angeles. It uses the aggregate function sum function to add up the salary values. Look at the yellow box. The output indicates that the total sum of salaries for employees in the Los Angeles city is 115,000.00, that is 60,000 plus 55,000. The sum of salary column represents the aggregated sum of salaries for all employees in Los Angeles based on the conditions specified in the where clause. Example 4. Look at the blue box. We type the statement, select sum of salary from employee group by city having city equals Chicago semicolon. This command calculates the sum of the salary column for rows where the city column is equal to Chicago. The group by city clause groups the results by the city column. The having city equals Chicago filters the results to only include rows where the city is Chicago. Look at the yellow box. The output indicates that the total sum of salaries for employees in the Chicago city is 102,000.00, that is 50,000 plus 52,000. The sum of salary column represents the aggregated sum of salaries for all employees in Chicago based on the conditions specified in the group by and having clauses. Example 5. Look at the blue box. We type the statement, select city, sum of salary from employee group by city semicolon. This command retrieves two columns, city and the sum of salary for each city. The Group by City clause groups the results by the city column, and the sum of salary column represents the aggregated sum of salaries for each city. Look at the yellow box. The output shows the total sum of salaries for each unique city in the employee table. Each row represents a different city along with the corresponding sum of salaries for employees in that city. Let's see about using min function. This function returns the minimum value in the given column. Example 1. Look at the blue box. We type the statement, select min of salary from employee semicolon. This command calculates the minimum salary value from the salary column in the employee table using the aggregate function min function. This output indicates that the minimum salary in the employee table is 50,000.00. The min of salary column represents the smallest salary value found in the dataset. Example 2. Look at the blue box. We type the statement, select min of salary from employee group by city having city equals Los Angeles semicolon. This command calculates the minimum salary value from the salary column for rows where the city column is equal to Los Angeles's. The group by city clause groups the results by the city column, and the having city equals Los Angeles's filters the results to only include rows where the city is Los Angeles's. The output indicates that the minimum salary for employees in the Los Angeles city is 55,000.00. The min of salary column represents the smallest salary value found in the dataset for employees in Los Angeles based on the conditions specified in the group by and having clauses. Example 3. Look at the blue box. We type the statement, select city min of salary from employee group by city semicolon. This command retrieves two columns, city and the minimum salary for each city. The group by city clause groups the results by the city column, and the min of salary column represents the smallest salary value for employees in each city. So the smallest salary amount of New York is 50,000, Los Angeles is 55,000 and Chicago is 50,000. Other cities have only one record, and hence the minimum value is as such. The output in the yellow box shows the minimum salary for employees in each unique city in the employee table. Each row represents a different city along with the corresponding minimum salary for employees in that city. Let's see about using max function. This function returns the maximum value in the given column. Example 1. Look at the blue box. We type the statement, select max of salary from employee semicolon. This command calculates the maximum salary value from the salary column in the employee table using the aggregate function max function. The output indicates that the maximum salary in the employee table is 64,000.00. The max of salary column represents the highest salary value found in the dataset. Example 2. Look at the blue box. We type the statement, select city max of salary from employee where city equals New York semicolon. This command retrieves two columns, city and the maximum salary for rows where the city column is equal to New York. The max of salary column represents the highest salary value for employees in New York. The output indicates that the maximum salary for employees in the New York City is 55,000.00. The query combines the max of salary aggregate function with a where clause to focus on employees specifically located in New York. Example 3. Look at the blue box. We type the statement, select max of salary from employee group by city having city equals Chicago semicolon. This command calculates the maximum salary value from the salary column for rows where the city column is equal to Chicago. The group by city clause groups the results by the city column, and the having city equals Chicago filters the results to only include rows where the city is Chicago. The output in the yellow box indicates that the maximum salary for employees in the Chicago city is 52,000.00. The max of salary column represents the highest salary value found in the dataset for employees in Chicago based on the conditions specified in the group by and having clauses. Let's learn about using average function. Example 1. Look at the blue box. We type the statement, select average of salary from employee semicolon. This command uses the aggregate function average to calculate the average, mean, value of the salary column for all rows in the employee table. The output in the yellow box indicates that the average salary for all employees in the employee table is 54,800. The average of salary column represents the mean salary value calculated across all rows in the dataset. Example 2. Look at the blue box. We type the statement, select average of salary from employee group by city having city equals New York semicolon. This command calculates the average average of salary for employees grouped by the city, group by city. It includes a filter, having city equals New York, to only show results where the city is New York. Look at the yellow box. The output indicates that the average salary for employees in the New York City is 52,500. That is 50,000 plus 55,000 divided by 2. Let's learn about using count function. This function returns the number of rows in the given column. Example 1. In the MySQL prompt, we type the statement, select count star from employee semicolon. This command uses the aggregate function count star to count the total number of rows in the employee table. The output in the yellow box indicates that there are 10 rows, records, in the employee table. You can refer the employee table holding 10 records in the green box. The count star column represents the total number of rows in the dataset. Example 2. In the MySQL prompt, we type the statement, select city, count of, salary, from employee group by city semicolon. This command retrieves two columns, city and the count of salary values for each city. The group by city clause groups the results by the city column, and the count of, salary, column represents the number of occurrences of salary values for each city. The output in the yellow box shows the count of salary occurrences for each unique city in the employee table. Each row represents a different city along with the corresponding count of salary values for employees in that city. You can check the green box for reference. City New York, Los Angeles, and Chicago each holds 2 records. The remaining cities holds 1 record. Example 3. In the MySQL prompt, we type the statement, select count star comma, sum of, salary, from employee group by city having city equals Chicago semicolon. This command retrieves 2 columns, count star and the sum of salary for rows where the city column is equal to Chicago. The group by city clause groups the results by the city column, and the having city equals Chicago filters the results to only include rows where the city is Chicago. The output in the yellow box indicates that there are 2 employees in the Chicago city, and the total sum of their salaries is $102,000. The count star column represents the number of occurrences, employees, and the sum of, salary, column represents the aggregated sum of salaries for employees in Chicago based on the conditions specified in the group by and having clauses. SQL Joins, Cartesian product, equi-join, natural join. Let's learn about SQL Joins. What is the meaning of join? Join means to combine something. In case of SQL, join means to combine 2 or more tables. Now come to the definition of SQL join clause. It is used to combine rows from 2 or more tables in a relational database. It is based on a common field, related column, between the tables. How can you query with join? When using join in a query, more than one table is specified in the from clause. Join process or function. The process or function of combining data from multiple tables using the join clause is referred to as a join. Some key points to remember about SQL joins. SQL extracts data from related tables using physical or virtual joins. Joins involve specifying conditions on related attributes using the where clause. Unlike Cartesian product, joins retrieve specific related data. The join clause is used in SQL, and conditions are specified within the from clause. Typically, related attributes are a primary key in one table and a foreign key in another. When using examples, you can understand better. First, let's learn about the types of SQL joins. Cartesian product, cross product, equi-join and natural join. We are going to learn this in detail. Cartesian product, cross product. The Cartesian product is also known as cross product or cross join in SQL. It is a binary operation denoted by cross that combines 2 sets or relations. The degree, number of attributes or columns, of the resulting relation is the sum of the degrees of the 2 original relations. The number of tuples in the new relation is equal to the product of the number of tuples in the 2 tables or relations involved in the Cartesian product. Example, if A equals 1, 2, 3. And B equals A, B, C, find A cross B, Cartesian product for A cross B is 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B and 3C. So, columns after Cartesian product equals 1 plus 1 is equal to 2, rows after Cartesian product equals 3 cross 3 is equal to 9. Let's see an example for Cartesian product. Look at the blue box. This is a student table containing 5 records, named Joel, Steve, Jenny, Daniel, and Emily. Look at the yellow box. This is an instrument table containing 2 records, name keyboard and guitar. Now, look at the green table. Cartesian product of student cross instrument. Look at the query in the green box. Select name, _name from student, instrument semicolon. Therefore, a Cartesian product is formed when no join conditions exist or are invalid. When we perform Cartesian product between 2 tables student and instrument, all the rows in the first table student are joined to all the rows in the second table instrument. Look at the output in the green box. Joel guitar, Joel keyboard, Steve guitar, Steve keyboard, Jenny guitar, Jenny keyboard, and so on. Using Cartesian product operation results in a large number of rows as the output, so it is seldom used, that is rarely used. Next we learn about the equi-join. An equi-join is a simple SQL join condition that uses the equal to sign as a comparison operator for defining a relationship between two tables on the basis of a common field, that is, primary key and foreign key. The syntax is select column 1, column 2 goes on, from table 1, table 2 where table 1 primary key column equal to table 2 foreign key column semicolon. Let's see an example. Look at the blue box. First we create a database named school. Next look at the yellow box. We are using the database school. Next look at the green box. We are creating a table student with roll number as int data type and primary key. Look at the red box. We are inserting 3 records. Now look at the pink table on the right side of the screen. Yes, you can see the table student with 3 records. Look at the blue box. We create another table named fees. Here, roll number integer data type, fees integer data type foreign key of roll number references student of roll number. Look at the green box. We are inserting values into table fees. Watch out that we inserted only fees for roll number 3 and 1. Because, in some cases, students wouldn't have paid the fees. So in the output it returns null value. Look at the pink box. The table fees looks like this. Now let's write a query with equi-join. You can see the table student in the green box. Table fees in the blue box. Now look at the yellow box, the statement in the MySQL prompt. Select a.rollno, a.name, b.fees from student a, fees b, where a.roll number equals b.roll number semicolon. First you have to understand this query. In this query, we have used table aliases. A table alias is a temporary name given along with the table name in from clause. To cut down on the amount of typing requirements in your queries, you can use table aliases for table names in select and where clauses. In the given select statement, A and B are the alias names, alternate names, for the table's student and fees, respectively. So, we can always use alternative name in place of primary name for the two tables to be joined. So now look at the output in the red box. The two table contents are joined together. Column name roll number, name and fees are joined together, which matches the roll number in both tables. You can also perform equi-join by using join keyword followed by on keyword and then specifying names if the columns along with their associated tables to check equality. The syntax is select column 1, column 2, from table 1, join table 2, on, join underscore condition, semicolon. The same query can be written using join clause. Look at the yellow box. In the MySQL prompt, we type the statement, select a.roll number, a.name, b.fees, from student a, join fees b on a.roll number equals b.roll number semicolon. In this query, student a and fees b are the aliases for the student and fees tables, respectively. The join clause is used to combine rows from both tables based on the common column roll number. The on keyword specifies the condition for the equi-join, in this case, a.roll number equals b.roll number. This query is equivalent to the original query but uses the explicit join syntax with the on keyword for better readability and consistency. Equi-join is further classified into inner join and outer join. Outer join is classified into left outer join and right outer join. Let's discuss about the inner join or intersection. Intersection of common rows. Inner join retrieves only the rows that have matching values in the specified columns from both tables involved in the join, resulting in the intersection of the two tables. Look at the picture below. The inner join is the intersection of table 1 and table 2. Equi-join subset. Inner join is a subset of equi-join, where the join condition is based on equality between columns, and it eliminates rows where the join condition evaluates to null, ensuring that only matching rows are included in the result set. Let's see an example. Look at the green box. It's the student table. Look at the blue box. It's the fees table. Now look at the yellow box. In the MySQL prompt, we type the statement, select a.roll number, a.name, b.fees from student a, fees b, where a.roll number equals b.roll number, order by a.roll number semicolon. The query retrieves the roll number and name columns from the student table and the fees column from the fees table, where there are matching roll number values between the two tables. The result set is then sorted in ascending order based on the roll number column from the student table. Look at the query again for more explanation. First we look at the table alias and columns. We are selecting a.roll number, a.name. These refer to the roll number and name columns from the student table aliased as a. Next we have b.fees. This refers to the fees column from the fees table aliased as b. Next we see the join condition. Where a.roll number equals b.roll number, this is the condition used for the join, specifying that the roll number column from table a, student, should match the roll number column from table b, fees. This ensures that only rows with matching roll number values from both tables are included in the result. Instead of where clause, we can use inner join also. In the next screen, we can learn how to use inner join instead of where clause. Last we have order by clause. Order by roll number. This clause orders the result set based on the roll number column from table A, student, in ascending order. Look at the red box. Roll number 1 holds the name Alex with fees 1,000 and roll number 3 holds the name Johnson with fees 1,500. Roll number 2 with name James does not match with fees in the table fees and hence not displayed in the result. Now we have a brief explanation. Inner join retrieves only the rows that have matching values in the specified columns from both tables involved in the join, resulting in the intersection of the two tables. Look at the picture. Table student has the alias name, A, and table fees has the alias name B. Here roll number column is marked in yellow, name column in green and fees column in blue for your easy reference. Now look at the red box below. The second line of the statement or query in the MySQL prompt. The inner join clause explicitly specifies the join condition on A.roll number equals B.roll number, indicating that only rows with matching roll number values from both tables should be included in the result. The alias A and B are used to refer to the student and fees tables, respectively, just like in the original query. The order by clause remains the same, sorting the result set by roll number from table A in ascending order. The same resultant table can be seen below after executing the query. Let's learn about the outer join. Outer join is classified into left outer join and right outer join. Let's learn about the left outer join. The left join keyword returns all rows from the left table, table 1, with the matching rows in the right table, table 2. The result is null in the right side when there is no match. Let's see an example. Look at the green box. It's the student table. Look at the blue box. It's the fees table. Now look at the yellow box. In the MySQL prompt, we type the statement select A.roll number, name, fees from student A, left join fees B, on A.roll number equals B.roll number semicolon. Now, in this query look at the table alias and columns. A.roll number. This refers to the roll number column from the student table, aliased as A. Name. This refers to the name column from the student table, as it's not explicitly aliased. Next is fees. This refers to the fees column from the fees table, aliased as B. Look at the second line. From student table alias name, A, next we can see the join condition. Left join fees B on A.roll number equals B.roll number. This specifies a left join operation between the student table A and the fees table B, where the join condition is that the roll number column from table A, student, should match the roll number column from table B, the fees. Let's view the result set. The query retrieves all rows from the student table, A, regardless of whether there are matching rows in the fees table, B. If there are matching rows in fees, the corresponding fees value is included, otherwise, null is returned for the fees column. Explanation of left join. A left join returns all rows from the left table, student A, and the matched rows from the right table, fees B. If there is no match, null values are returned for the columns from the right table. The result set would contain the roll number and name columns from the student table, along with the fees column from the fees table, where available. This query essentially fetches information about students' fees, including those who haven't been charged any fees, hence utilizing the left join to ensure all student records are accounted for. Look at the red box. Roll number 1 and 3 holds fees value 1,000 and 1,500 respectively. But roll number 2, James' record holds the value null, as on the right side table named fees, doesn't hold any match. Let's learn about the right outer join. The right outer join keyword returns all rows from the right table, table 2, with the matching rows in the left table, table 1. The result is null in the left side when there is no match. Let's see an example. Look at the green box. It's the student table. Look at the blue box. It's the fees table. Now look at the yellow box. In the MySQL prompt, we type the statement, select statement. This part of the query specifies the columns that you want to retrieve from the result set. In this case, you're selecting roll number and name from table student, aliased as A, and fees from table fees, aliased as B. Next line, we have from clause. Here, we're specifying the tables from which we want to retrieve data. We're performing a right join, which means we want to include all rows from the fees table, the right table, and only the matching rows from the student table, the left table. The join condition 0n A.roll number equals B.roll number ensures that only rows with matching roll numbers between the two tables are included in the result. Order by clause. This clause is used to sort the result set based on the fees column from table fees, aliased as B, in descending order, DESC. So, the query will return a result set that includes the roll number and name from the student table and the fees from the fees table, where there are matching roll numbers between the two tables. The result will be sorted based on the fees column in descending order. Look at the red box. Records are displayed in descending order. Record 3 holds name Johnson with 1,500 fees and Record 1 holds name Alex and 1,000 fees. Let's revise the types of joins. Inner join. This type of join returns only the rows where there is a match in both tables. Left join, or left outer join. This type of join returns all the rows from the left table and the matched rows from the right table. If there is no match, null values are returned for the columns from the right table. Right join, or right outer join. This type of join returns all the rows from the right table and the matched rows from the left table. If there is no match, null values are returned for the columns from the left table. In SQL, the join in which only one of the identical columns exists is called natural join. Let's see the explanation. Listen carefully. A natural join is a type of join operation that automatically matches columns with the same name across two tables. When you perform a natural join, the resulting table includes only the columns that exist in both tables, and it combines the rows from both tables where the values in the matched columns are equal. It is similar to equi-join except that duplicate columns are eliminated in natural join that would otherwise appear in equi-join. Now come to the second point. In natural join, we can also specify the names of columns to fetch in place of star, which is responsible for the appearance of common column twice in the output. Listen carefully. The SQL natural join is a type of equi-join and is structured in such a way that columns with the same name of associated tables will appear only once. There are two conditions for natural join. First condition is, the associated tables have one or more pairs of identically named columns. Second condition is, the columns must be of same data type. Note that, in natural join, the join condition is not required. It automatically joins based on the common column value. Natural join is an alternative method to equi-join. The syntax of natural join is select star from table 1, natural join, table 2 semicolon. Let's see an example. We have the two tables student and fees on the top of the screen. Now, we are going to use natural join with these two tables. Look at the yellow box. In the MySQL prompt, we type the statement, select star from student natural join fees semicolon. This query performs a natural join between the student and fees tables based on the common column roll number. It retrieves all columns from both tables where the roll number matches. It effectively combines the data from both tables based on the common roll number. Now, look at the red box. In the result of the final query, you can see that it combines the data from both student and fees tables, showing the roll number, name, and fees for each student where there is a match on roll number between the two tables. So roll number 3, named Johnson and fees 1,500 and roll number 1, named Alex with fees 1,000 are displayed. Thanks for watching. If this video helped you, don't forget to like, share, and subscribe to Sally and Bytes for more tech lessons. Keep practicing SQL, and see you in the next video.